Good morning, everyone. So I'm Aidan, and my company is Cloud Mechanics. So when I'm being Batman, it's Cloud Mechanics. My daytime job when I'm being Bruce Wayne, seeing as we are in Gotham, I work for a distributor in Ireland called Micro Warehouse. So I deal in what's referred to as Cloud Solution Provider, or CSP, so the channel of Microsoft Cloud Services for Microsoft partners and resellers, and all the fun and games that entails. And for the last 4.5 years, I've been teaching Azure to Microsoft partners, and since February of this year, been teaching on my own in the European Union. And as Alex said, I'm looking into bringing our training over here to the US, because obviously it's a huge market of English speakers, and I don't speak German or French. I speak very bad French. So obviously the US is a market for me to think about. I'm a Microsoft MVP. I survived the recent cull where they got rid of about 20% of us. I'm an Azure MVP. For the previous 9-10 years, I was a Hyper-V MVP, but I haven't done anything with Hyper-V in 2 years. So it kind of made sense that they cut me from that. I blog on aidanfinn.com, and you'll find me writing a good bit on petri.com as well. So I do 10 articles a month for them, almost entirely on Azure content. It's pretty much everything that I talk about in these sessions has been covered in either 500 or 1,000 words in Petri, or over a series of articles in Petri. And that was yesterday, a few blocks up from here. That was taken yesterday, a few blocks up from here.
Is that before they arrested you?
Yeah. There's a small little place. If you look for a bar called Johnny Utah's on Google Maps, across the road there's this very small little, you couldn't call it a museum because it's too small, but it's got a shop for the FDNY. So if you want to get a photo inside of a fire truck and all that sort of thing with the jacket and the helmet, go there, stick 10 or 20 bucks in the cash box outside first, and they'll look after you. We figured that out.
They forgot to tell you you're not allowed to drive the way.
It's not a full-size truck, it's only the cab. And my company, Cloud Mechanics, well, it's myself and my wife's company. We write and deliver custom-written, up-to-date, as of that morning, Azure training. So we have a course at the moment called Starting Azure Infrastructure. It's 2 days. First day is long, second day is not quite as long, and it's lots of hands-on labs, lots of stuff. What I'm doing today is actually longer than what I do on the networking in this, because you only have so much time because it's hands-on, and we tend to focus on people learning by doing rather than me talking. So we've a lot of fun doing that. It was interesting the first one we did because it seemed to be mostly E2E attendees, thanks to Barcelona. Thank you, Alex. And the E2E crowd in Europe are talkative, and to say the least. So it was a lot of fun. So what am I covering? An awful lot of stuff. We thought, myself and Alex talked, and we decided a masterclass on networking. And then when I sat down to write this a couple of months ago, I realized that's a big topic, a very, very big topic. You could probably spend a day just doing, maybe this. So 4 hours for all of this. If there's nosebleeds, there's disclaimer forms, is there? Right, so I always do what's an Azure to start off with, because not everybody is familiar with what an Azure is. It's Microsoft's infrastructure and platform cloud. It's part of their whole cloud thing. You hear all this BS out there about Amazon being the biggest cloud out there. That is BS that comes from the New York Times and other ill-informed journalists. The biggest cloud vendor out there is Microsoft. When you take Office 365, CRM 365, and Azure and the other cloud services, they are the number one cloud vendor out there. They're number two in terms of platform and infrastructure. They are behind AWS, but they're growing twice as fast. So watch this space. In Europe, what we're finding is that when a business is looking at cloud, 2 out of 3 times it's Azure. In the US, cloud was adopted earlier than in Europe, so it tends to be more AWS focused. However, we're seeing lots of interesting stories like Wall Street in the last couple of days, or Walmart in the last couple of days.
The reason that people go for Azure has nothing to do with Microsoft says, oh, we're going to give 95% discount.
No. Yeah, they don't do that anymore. So the whole EA thing, when someone bought an enterprise agreement and they were given, $100,000 worth of Azure for free, they're not allowed to do that internally anymore. And the salespeople get punished for doing that. They get further away from their sales targets if they do that because they're measured on adoption. They're actually measured on adoption if people use it rather than if they get it for free, which is better for the rest of us, to be quite honest, especially those of us who are trying to sell it. So it does lots of different things. The networking side of things, people think of it as being infrastructure, so virtual machine related stuff, but what we're seeing is on the networking side that it's becoming more and more important on the platform side for the developers. And in a talk I do about platform or platform as a service for IT pros, I explain why the whole digital transformation is actually good for us. It's not actually killing us off because they are having to bring networking back into things to start giving compliance and security for things like PCI DSS and all that good stuff. So the network has become more and more important. And you'll see some of that in the slides later on. Azure is extremely big. So in North Europe, which is Dublin, which is west of West Europe, which is in Amsterdam. I won't explain why I think that happens because half of you are American and you'll attack me. But it might have something to do with lack of geography skills. There are 54 announced regions. There's something like 45, 46 that are in production right now. And they are spread all around the world. Here in the US, there's obviously a lot of different regions. There's the public regions, and then you have private regions. Private regions are government type regions. So there's a bunch of them here in the US. There's DoD regions, there's Gov regions. And then we have what are referred to as sovereign regions. So we've got Azure Germany, because most Germans believe that they cannot use a foreign-owned cloud. Turns out that only legally applies to the Lutheran Church in Germany. It doesn't apply to other businesses. It's a rather interesting thing, but it's a myth that has effectively become a law because enough people believe it. And then there is Azure in China, which is owned and operated by a Chinese company on behalf of Microsoft. 1.6 petabytes bandwidth per data center. And there's multiple data centers per regions. So each of those little dots is a region. Multiple data centers. Dublin has 11 data centers, I believe, at the last count. All in one small place, about 1.5 miles wide. And within each of those data centers, there's a room, which Microsoft refers to as a colo. Within one of those rooms, there are over 50,000 physical Hyper-V servers. So if anyone in here thinks Hyper-V cannot scale, fuck you very much. They probably own the second largest WAN in the world as well. And it looks something like that. Lots and lots of fiber. And this is, Google would not be number one, I would say. It's probably going to be one of these companies like Hibernia Networks, so one of those guys. Microsoft do use Hibernia Networks, so this particular line going into Derry in Northern Ireland is a Hibernia Networks line. Yeah.
I find it will help with internet.
It's one of the best places to get broadband if you're with the right ISP.
I get like 30 megabits. Awesome.
I have a friend who actually worked for Hibernia Networks, and he used to complain about the speed of networking for Azure. And I was like, Dave, seriously, you have more bandwidth than anyone, and you are the supplier to Azure. So stop being a fool. So the WAN grew by 700% in the last 3 years. 2,500 WAN partners, so peerings, 4,500 peering locations, 33,000 miles of lit fiber. It's ridiculous. The line that goes from the US over to Spain was recently dropped down the ocean. It's co-owned by Microsoft and Facebook. And it's some ridiculous amount of bandwidth. These petabytes per second type things. You can download a lot of torrents very quickly on these lines. And you see it if you fire up a VM in Azure, like a good high-spec VM, and because your bandwidth is actually based on the number of cores, physical cores assigned to the VM. It's not a price banding thing. And then you run a broadband speed test on that thing, you will see some nice numbers.
So the pirate base basically on Azure.
Should be. So speaking of performance, first thing you typically look at when you're looking at performance for a web application is the speed to resolve your DNS names. How quickly can you do it? And typically your website testers will look at this first. How quickly could I resolve www.cloudmechanics.com to an IP address? Now most people will go to an ISP or a registrar, like your GoDaddy's or whatever, and they'll have maybe so many DNS servers around the world. Or if it's a smaller ISP, so many DNS servers in a country. And that means when people are accessing your service from further away, there's an increased latency. So Microsoft have a solution. It's one of these micro-cost services. And there's a number of services that we can use in Azure. And when we're pricing up stuff for customers, we actually don't bother pricing it up. And this is one of them. Because A, it's very difficult to price up, and B, the effort to price it up will cost more than the actual price. So we just tell people, back up, we're going to charge you a little bit more for that, or estimate it's a bit higher, and that will absorb some of these micro costs. And DNS is one of these things. What I can do is I can go to GoDaddy, and I actually did this for cloudmechanics.com. You can see the numbers down here. And you'll be sharing up PDFs or slides and stuff, Alex?
Whatever you tell me.
Okay, I'll give you the PDFs.
Those who are here in the room.
Cool. So I'll share out the PDF so you can see the numbers properly. But basically my old domain, aidenfinn.com, for my blog, which is, the DNS is a company in Ireland called Black Knight. They're a very good company. They have like 3 or 4 name servers around Ireland and I think Amsterdam. They're double to triple the numbers than the Cloud Mechanics name resolutions, which are hosted in Azure. So what I did with this is I won cloudmechanics.com on a GoDaddy auction, $10, thank you very much. And I changed the name servers to the Azure name servers. And then I created a domain on Azure for my domain, cloudmechanics.com, and I create my A records in the Azure portal. My C names, whatever it is.
Do you use a MVP credit for that?
No. That would be not allowed.
Oh, really?
Yeah, it's an MSDN subscription we get. That's not allowed. It's for test and dev purposes only, Alex.
You can't use it in production. Nobody does.
How much they charge for DNS?
It's a micro charge. It's based on so many million name resolutions.
Okay, so it's based off.
Yeah, and it's one of these things where the price is like the 5th decimal point.
Can you do delegation?
Probably. There's stuff that's either not there or coming that I can't talk about.
Okay.
I have to be very careful about DNS and what I say, what's there and what's not.
Do I have enough services that I could do DSLB with it?
I don't, DSLB.
Like what the NetScaler do, global server load balancing?
Where that A record would have an authoritative DNS server, which would be the NetScaler, so they could go, hey, go here versus go there,
Yeah.
go that way.
That I don't know.
Yeah.
And you have to have delegation, and you have to be able to delegate a host name or a domain name.
That I don't know. As I said, on this particular area, I have to be very careful
Okay.
because there's a lot of things I know that are under NDA. And I'm unclear about where those things are in public.
Okay.
This particular piece, which is DNS. It does support a whole crap load of names for public zones. We can also do private zones as well. So in terms of benefits for using this thing, management. One of the things I hate about DNS registrars is they all have different UIs and they're all a pain in the ass. For example, if I'm setting up Office 365, there's a whole bunch of records I've got to set up for that, and usually the UIs from those registrars don't support doing those configurations. I've got to open up support calls. Whereas with Azure DNS, it's basically like using Windows DNS. I can go in and I can do whatever I want. I can also do it using PowerShell or Azure CLI, which is basically bash commands for Windows, Mac OS, and Linux. The fact that I can script this stuff also means I can start doing orchestrated things. So if I want to do A/B testing production and switch production systems in or into test and test into production and stuff like that, I can orchestrate that. So great for DevOps type deployments. If I want to do failovers, so move my stuff from East US to West US in the event of a disaster, so another hurricane decides to blast Virginia, I can do that. And not just move my stuff over, but change my DNS records so that they update to my new A records. And there's other fancy things I can do in that failover scenario we'll talk about later. Simplified management. You start to inherit the many certifications that Azure has for compliance and security. So you no longer have to go to that DNS registrar to find out what they have. You just go to the Microsoft Trust Center and you can see exactly what Microsoft has, and you can download the audit reports if you need to supply that to your employer or your customer. Built-in DDoS mitigation. Number one way, or an easy way of attacking any company, is to bring down their website by attacking their DNS servers. So no one can actually resolve that name. Azure has the ability to deal with that. 100% SLA, it's the only Azure service with that. Because this is hosted in, once you put your domain up in Azure, it's actually hosted in every Azure region. So now it's a global presence. So if one region has a problem, people will just resolve off the next nearest region. That boosts your performance, because now your names are closer to your customers or your suppliers or whatever it is. And you're taking advantage of the networking that Azure has as well and its connectivity. We also have the ability to do private zone resolution. So if you want to run VMs in Azure and you want them to resolve off of non-VM services, so using Azure's own DNS services, you can do that. It's in a managed preview at the moment. Well, managed preview is different to a normal public preview. Normal public preview is typically supported by Microsoft unless they say it's not. A managed preview is one where you have to apply to get in, and then the features are typically very restricted. It's a very early phase of release from Microsoft. The idea here is you will have multiple virtual networks, typically. You'll have one virtual network where there's some application that needs to register its domain names, and that will be a registered or registration VNet. Then you'll have other networks where there will be client applications or client servers or even client RDS or Citrix boxes that need to resolve those names, and they'll be associated with the zone as resolution VNets. And then your VMs just register their names, their IP addresses, name resolution happens. The management for this is all PowerShell and API. There is no UI for the private zones at the moment. And there's a lot of stuff going on with that at the moment that is not public, but there is a lot of investment going on. Typically what we do see happening when people need private DNS resolution is they fire up low-cost VMs, whether it's domain controllers or low-end Linux boxes or whatever it is, low-cost B-series VMs, and they quite happily will handle that role. The idea with this is that you won't even need those low-cost VMs. But it's a managed preview, so it's not anywhere near ready for production at this point. So what does it look like? Well, to be quite honest, it's quite simple. So go to my dashboard. There's my E2E dashboard. And so what you're looking at here is the Azure portal. This is a customized dashboard that I've shared out with multiple users in my tenant or my domain, if I want to think of it that way. And it's a bit small and stuff. So basically what we can do with these dashboards is create a customized environment. So if I want to work on a particular application or a particular demo, I will set up one of these dashboards. I'll pin performance charts, shortcuts, whatever it is that makes my life easier. And I have a shortcut to my DNS domain. And this is just create records, resolve names, resolve IP addresses. I can create A records, quad A's, PTRs, a whole bunch of different things in there. It's a long list. And I've got a bunch of them in there. The UI is very, very simple. Create a record. Give it a pick whatever it is I need. Give it a name. So E to EVC.
That's a private solution.
This is public. So this will be e2evc.joelway.com. And then bang in the IP address. And I can set my custom TTL as well. How do I set that up with my registrar? It's actually pretty simple. These are the name servers that Azure advertises. Now there's a lot more servers. They're basically using a load balancing service. So when the client is sent to one of these, they're sent to the closest one of these around the world. So you basically take those, replace the name servers in your registrar's DNS zone, and that's it. It's a simple setup. It takes like 2-3 minutes to set up the whole thing. And when you do a name resolution speed check afterwards, you'll find you're probably getting twice as fast, 3 times as fast name resolutions.
So can you have a website on GoDaddy with DNS on Azure?
Yeah,
Yes.
absolutely.
So I can essentially go into the command line of GoDaddy and change all DNS servers to Azure.
Yeah, that's what I did with Cloud Mechanics. Exactly what I did. So I bought it on GoDaddy and created the joelway.com there. Then went back to GoDaddy after copying the name servers from up here, and went into the zone on GoDaddy and changed the GoDaddy name servers to the Azure name servers.
And visually, you see that the website loads faster.
As a human, I don't think you necessarily will. And the testing tools will see it. If it's a heavily trafficked site, you probably will notice it. So that the time to actually start loading should improve. The time to load won't change, but the time to start loading will change. So the developers typically want everything to be as fast as possible. No idea.
As far as I know,
Because usually it's outsourced.
as far as I know, AWS.
Right, let's get to talk about some basics. Virtual networks. So all virtual machines, if you're creating them today, they should be ARM or Resource Manager virtual machines in Azure. We've got 2 types of Classic, which is referred to as ASM. Microsoft hasn't developed that now in 3 or 4 years. ARM or Resource Manager resources is where all the development has been in the last 4 or 5 years.
But the question, why do they still talk about the classic if it's not
Backwards
maintained?
compatibility, because a lot of people just haven't bothered converting their resources to ARM.
But they cannot do any more than the classic. So
They don't want to, because Resource Manager works much better. It's where all of the management work goes on.
but do they have a roadmap when the classic will be killed once and forever?
If they do, they haven't advertised it. They probably can't because there's big customers out there using it and just haven't gone through the process.
No, because the customers get confused when someone wants to go in Azure and then they read that, they say, oh, there's reference to classic. Where do they find the classic? But there's no classic. Or Azure says something like
So
this.
it depends how you or where you got your Azure from. So if you get credit cards or trial, credit cards certainly, you can create classic resources.
Still.
Yeah. If you have an EA, you can create classic resources. If you're in CSP, you can only do ARM. So it depends on what channel you bought your Azure from. But ARM virtual machines must be on a virtual network. Classic didn't have to be. It was just a weird thing where they were just connected to the internet in some magical, mysterious way. The virtual network is responsible for all communications between virtual machines to and from the internet, and also it's essential for communications back to on-premise. if you wanted to run your virtual machines privately, but just up in the cloud. Some parts of the platform that's used by developers, PaaS, are also available to be connected to virtual networks. So if I create databases, I can connect them to a virtual network. If I create storage accounts, I can connect them to a virtual network. And that's the sort of thing that's important for PCI DSS. It privatizes the connectivity between virtual machines and those resources. And we'll also look at later on how web apps. Web apps is a way of running Tomcat on Linux or iOS on Windows without actually caring about virtual machines. Microsoft runs the virtual machines under the covers for you. It's a very easy way to deploy any web-based application and do it at elastic scale as well.
Sort of like containers.
Yes and no.
The
On
principle-
the Linux side, it actually uses containers. On the Windows side, it uses Windows virtual machines, dedicated Windows virtual machines.
All right, you just made them sit.
Yeah, no, they're, well, yeah, but you don't even see them, you don't care about them. Microsoft look after them for you, upgrade them, patch them, secure them, and all that. You just upload your code and work. So it's like using, you know, a web service from the likes of GoDaddy, but it's enterprise scale and enterprise functionality. You don't care. There's a VM there, but you don't care about it.
Yeah,
But it's, in this case, it's dedicated. Whereas GoDaddy, it's shared.
exactly, yeah, that's the main problem.
So what is a virtual network? Well, a virtual network does not physically exist. It does not have a VLAN. There are no VLANs here, which is great for me. I love talking about Azure networking because in my life, I have never, ever created a VLAN. I like being able to say that. But I can do all the cool stuff here in Azure apart from one thing, because I've never had a customer willing to pay for it. I'll talk about that a little later. So there's no physical switches, there's no ports, there's no physical routers, there's no VLANs to worry about. It is literally, I want a network, and I would like one or more subnets in that network. And then I'll figure out connectivity stuff. Very simple to set up. It takes a few seconds to create one of these networks. It's actually powered using a technology that's been in Windows Server since 2012 called Gw1. Network Virtualization GRE something.
Great.
It's a friend of mine explains it as being a dynamic VPN. If two machines need to talk to each other, the underlying fabric creates a tunnel between the two virtual machines, whether they're on the same host or in different data centers or different regions around the world. And those two virtual machines can then talk to each other like they're on the same network. It's a very cool technology, and it comes in very handy when we start looking at connecting virtual networks later on in a feature called peering. We can create these using private IP address ranges, so your 10s, your 172s, your 192, 168s, and you can also use your own public range if you wish to do so. And that's not very well known, but you can actually do it. So if you have your own Class B or whatever it is, you'd like to use some of that in Azure, you can use it. If you use these, then you can start doing natting and stuff like that. We'll have a look at that later on. When you create that virtual network, it must have one subnet. So it's like when you create a LAN in a small business or a branch office, it must have one VLAN within it. So your VLAN 0 or whatever it's called. So here we have a simple example. A virtual network, 10.0.0.0/16. And it must have one subnet. So I'll have a subnet there of 10.0.0.0/24. And when I create that subnet, automatically Azure will set up a default gateway. So if anything on that subnet wants to route to anywhere outside of that subnet, it will automatically go through that default gateway. No matter what you do inside the guest OS, as soon as the packet hits the NIC, it will go through that default gateway. So some developer can try to set up their own custom routing inside the OS. Hard luck. As soon as the packet hits that NIC, the network takes over.
So you don't have to add the gateway network anymore?
That's a different thing. We'll look at that later.
Oh, okay.
But if you want to isolate your VM, if you don't want to have a gateway, how do you isolate?
I'll show you that later. The first address available in here will be the fourth address. The first address is the default gateway. .2 and .3 are reserved for Azure usage. We can define our own DNS services if we wish. By default, if I create two VMs in the same deployment, the same network, they will be able to resolve each other's names using Azure's own DNS. It just automatically happens. However, if I want to define my own DNS, let's say I want to use Google's DNS, or I want to use OpenDNS, or I want to set up my own domain controller as a DNS server, I can take the ISP or the IP address of those services and assign it to say everything in this network will use these addresses for their DNS. So I can edit the properties of my virtual network and say the DNS servers for this network are 208.67.222.222 and 208.67.220.220. So now everything on that network, by default, is going to use OpenDNS for its name resolution. A virtual machine will connect to a subnet using a virtual NIC. A virtual machine can have more than one NIC. However, it's not that common to see it. It's typically appliances. There's no need for it for a normal workload machine running Linux or Windows. It's kind of pointless having multiple NICs. But you do see it, and it is typically things like firewalls, where they'll have 2 or 3 or 4 NICs. The number of NICs that you can assign to a VM is dependent on the number of cores that the VM has. Microsoft won't let you add NICs to a single core VM or multiple NICs to a single core VM because it cannot handle the interrupts. So it's kind of pointless.
Is there an option to run a NIC with a brain or not?
With a brain?
No, like Hyper-V was thinking that.
Oh, Hyper-V offloads and stuff. Yeah. So we can turn on SRIOV, for example.
You can.
Yeah. And you have to do that when you create the NIC and the
Do you have
VM.
a special mix for that?
Nope, because it's all software. Underlying, it's all Mellanox.
Right.
So
So how do they do that? But that NIC would not be a pass-through NIC, right?
no, it's SRIOV, so it's not discrete device access like in Hyper-V. It's, what do they call it in VMware? Is it VAAI or is that the storage thing? Yeah, Dave, VMware has an equivalent of SRIOV in Hyper-V, where there's a virtual function, which is the NIC, which talks about physical function on the physical adapter. That's what you get here. So it is the Hyper-V feature that they've just revealed.
Well, but should we move if you enable that? Usually if you enable the SRID, so you won't be able to, let's say, migrate.
Well, you can't migrate an Azure virtual machine anyway. So, and Hyper-V does allow you to migrate a virtual machine with SRIOV. Yeah, it disables it, moves the machine and re-enables it. So you might see a blip in latency while it's disabling and enabling. The important thing is with the NIC, it's the NIC that gets the IP configuration, not the VM. So the virtual network is going to supply an IP configuration for that VM when it powers up, and it will assign it to the NIC. This is important. Azure newbies get lost here, and they create a boo-boo here. I'll explain why in a slide or two. So, I create a VM. It will have a NIC connected to a subnet. When that VM powers up, it's referred to as being in an allocated state. And the virtual network will automatically assign an IP configuration to that NIC based on the subnet that it is in. So in this case, it's going to pick up .4. It's the first available address in that subnet. It will pick up the subnet mask based on the IP address configuration of the subnet. It will pick up the default gateway because, well, that's the first IP address in the subnet range. And it will pick up the DNS services that are defined by the virtual network. And all of that goes to the NIC. The OS boots up, and the OS thinks it has a DHCP server. There is no DHCP server. All the language for this is DHCP language because we're familiar with it. But there are no broadcasts on that network. In fact, you can't do broadcasts on that network.
Means that if you move network interface from one VM to the other, you will receive the same IP on the other VM.
Yeah, I've never tried that.
No, me, but it's just a question. If it's linked to the network
Yeah.
interface and you move network interface,
Yeah, it would.
you expect to have
It makes sense that that would be the case. That would make sense. And because the IP address is actually assigned to the NIC, yeah, it makes sense.
Because when you clone a VM, you clone the disk, not all
Yeah.
the VM. When
Correct.
The disk part of the VM is cloned. It's a copy to create a clone,
Yep,
and you assign a new interface.
yep. So, this IP address, taken from here, first available IP address. And it's dynamic. Which means if I power up another VM, it will get the next IP address, .5. That's the default behavior. Now in the Jeffrey Snover world, where we don't care about any individual machine, the machine has a problem, bang, replace it with another one. This is great. In the real world, where names and functions and IP addresses are important, this doesn't work so well. So let's say I shut down these two VMs and they become deallocated. Those IP configurations are handed back to the network at that point. Now, hold on, I boot up this machine. What IP address will it get? .4. Bit of a problem that this was a domain controller. So what we do is we edit the settings of the NIC to make the IP address static. Trick there is, if you're changing the IP address, it will reboot the VM. So watch out for that if it's a production workload. Sorry, Alex, was that the question?
No, I saw more about an Azure stack. Do you have a reservations in the Azure stack?
Not a clue. Never worked with it, never will. Don't have any customers who will ever use Azure Stack. Because the hardware is a ridiculous price. I think HP are starting at $400,000 for four hosts.
I mean, more like, is there an option to say that this VM number 1 should always get the 4?
Yeah, you're
Aside from
so it's
the
what
static part.
it's where you edit the NIC, and there's a little radio button. You change it from dynamic to static. You click OK.
But you cannot have reservations for any machines as per name.
No, it's the NIC. And the NIC is associated with the VM. It doesn't dynamically change. You would have to manually go and change that.
So I cannot make it the way that the VM, do you know that when it's booting out that it will always get 5?
It will because it's associated to that NIC. It's only if you cut that link.
But there is no consequence association like with the DHCP Mac versus.
Yeah, the MAC is the NIC. It's the exact same. It's the exact same in the end. So dynamic by default. You can also change the DNS servers at the NIC. So if this was a domain controller, I could say these DNS servers or settings should actually be the IP address of this machine. And then I could edit the NIC here and say it's DNS servers 127.0.0.1. And so we have two places we can customize the DNS servers: the network and the NIC.
And if you do that from the VM, what happens then?
If you change the IP address of the VM, you can no longer log into the VM.
From the ES?
Yeah.
Change it from the ES?
Yeah, you will never be able to log into the VM again unless you fix it. I think multiple ways of fixing it. So we cover that in the actual VM training, but we have the ability to log into a VM using the serial access console of Linux or Windows. So it doesn't require networking access at all. So if you can bash it or command line or PowerShell it, you can fix it. Just set it back to DHCP in the guest OS.
The main takeaway here is never touch network
Correct.
stack of the OS.
I do have that on the screen on my VM training class, but I don't have it here, I think. But yeah, never, ever change the IP address in the guest OS. Only do it in the Azure portal with a NIC. So I can add subnets. So there's 10.0.1.0/24, and if I have a virtual machine with multiple NICs, it can connect to multiple subnets inside the same virtual network. So in this particular network, I could have a virtual machine connecting to this subnet and this subnet. And if I add another subnet, it can connect to that too. And we'll see some scenarios why we do that later on when we look at architecture stuff. But it is typically virtual firewall appliances. Common question is, can I connect to two different virtual networks? The answer is no, you cannot. Can I change the subnet association of a VM? Yes, you can, very easily. Can I change the virtual network association of a VM? Not easily. You basically have to destroy the VM, keep the disks, that's where everything of value is, and recreate the VM from the existing disks and connect it to the correct virtual network. If you use managed disks, you'll do that in about 5 minutes. If you use that by storing VHDs in a storage account, break out your PowerShell manual, and good luck. There's no complete examples out there.
So you cannot have two RVM. You cannot have two RVM which would have connection to two VNets.
And they can only connect to one VNet. But you can connect two VNets together. We'll see when we get to architecture type stuff. So you can set up that configuration there. And that could be a firewall appliance, using this as an external network and this as an internal network.
Is that default gateway stay the same, or can you change it to point to?
You can change it to your heart's content in the guest OS and you'll break the machine.
Well, I know that, but I'm saying that the
You cannot change it. It is what it is.
You can change the route for the.
Yes, we'll talk about routing later.
Do they plan to change this?
No, they don't. It actually makes it easy. And this makes networking really, really easy, and it's hard to get it wrong. And I can add lots and lots of subnets. So let's create a virtual network. It sounds like it's very hard to configure all this stuff. It is actually very, very easy. So I can go create resource and networking, virtual network, and let's call it E2 EVC, Alex, and what address space would I like? So they do something cool here in the Azure portal. They give me an address, they suggest an address space that I have not used yet. So my typical tip here is treat every virtual network like a branch office. It should have a unique address range. You might not want to connect it to anything else today, but in a week, after you've got valuable systems running on it, you might want to connect it to another virtual network in Azure or to an on-premise network. And at that point, if you're using overlapping addressing, you won't be able to connect them because they can't route. So always use unique address ranges for your virtual network. And the Azure portal will steer you towards doing that. If I try to reuse one that already has been created, it will even warn me that it's already been created. Yep.
Does that include between tenants? So
Yes.
So it'll keep track of.
Oh no, you can connect between tenants, but it has no idea between tenants.
Or will you run into routing problems if you don't?
Because the two networks packets can't get from A to B. The fact that the networks are in different tenants, different on-premise and Azure, AWS and Azure, doesn't matter. If they're two same address ranges, you've got a problem. So the other tip of the day is don't do something like this, and I actually had a customer who did this. I had a customer who deployed that virtual network and deployed a single subnet in that virtual network with the same range to all 16 million IP addresses in one subnet. And then I was there to do a proof of concept workshop, and he said, oh, by the way, can I ask you a question? And he showed me this, and he said, well, I've got this customer, we've got two virtual machines in here, and they need another subnet, and it won't let me. Can you explain why? And then I had to explain networking basics to that. consultant who was charging €1,000 a day to his customers. I love that. So 10.7.0.0/16, and pick my subscription. I can put it into a resource group. A resource group is basically a bucket of administration for creating delegated or role-based access administration. So I can create a new one, and E2E, BC.
Is there any relation between the resource group and the network?
No.
No.
A resource group is like an OU in Active Directory. And resource groups exist for the same reason as OUs in Active Directory. Primarily, they're supposed to be a way of creating delegated administration. But the main reason people use resource groups is a way of organizing things. Sorry?
I see no mention of IPv6 in here.
So IPv6 is used for public addresses. It's not used for private addresses. So it's not there in private addresses, but it is available for public addresses. I have not encountered anyone using IPv6 yet. Has it become a thing over here?
But this is weird because back in the days,
Microsoft used to bash us over the head.
You remember it now?
Yeah, it was like you have to learn IPv6 and you have to learn PowerShell or you won't have a job in 5 years.
Yeah.
And what's it been since they started? 10 years?
10 years, yeah.
I still have a job.
But I think if anywhere, the Irish had more IPv6 addresses than anywhere else.
I don't think anyone was using them though.
Yeah, well, that's the difference.
And define my subnet, my range, click create, and probably in about 60 seconds that'll be done. So there we go. The job is running, and that'll be done in the background. That's better than the old days of hosting where you'd send off a ticket to the hosting company, and some CCIE would pull in their hair, end up with a hairline like me, and going, oh my god, more VLANs. And 3 days later you got a VLAN. And this, I need it, it'll be done in about 60 seconds. So what's it look like when it's done? So here is a virtual network. Let's expand it out. And it's got some subnets. I can see what devices are connected to it. There's nothing. I come in here to Ddos Protection. So I'm going to talk about this a little later on. Right, in fact, I'll talk about it now and skip the slides. We get basic Ddos Protection for free. So there is a system there that is doing its best to mitigate DDoS attacks. If we go to standard DDoS protection, we start paying for that mitigation service. And what they do with standard is they start using a machine learning system to learn the normal behaviors of networking within your network and your public interfaces. And if they see something abnormal, it'll get a bit more attention to see if it needs to be mitigated by the big Chrome robots that are protecting your network. You pay for that service, and as part of that payment, you also get insurance. So if your costs in Azure go up because of a DDoS attack, and standard DDoS protection hasn't stopped that attack, Microsoft will basically credit you for that expansion that has happened.
It's the same like with the SLA they have, isn't it? 99999, and then if you go
Or
lower.
which of the SLAs?
Yeah,
it's a similar type system. So, if they don't live up to their SLA offerings or promises, they credit you back.
They only credit you back for the time that the service is out, right?
Yes.
It's not like they credit you.
Well, for the entire month, no, because it worked. Here's where I can change my DNS servers. So I can come in and say I want custom DNS servers and bang in my IP addresses and click save. Service endpoints, mentioned in slides a little later on. If I add this functionality, it basically allows the platform features of Azure, like databases and storage accounts, to connect directly to this network. So instead of my VMs talking across the internet, which is basically just talking across Azure to those services, it will talk within the virtual network. The packets will not leave the virtual network. So that's important for your PCI DSS compliance.
Does it matter what region your other VMs are?
Can you connect on?
And if you create a virtual network, everything's in the same region. However, we can extend to other regions. We'll have a look at that later. Using more virtual networks. So creating the virtual network and all that good stuff, very, very easy, very, very simple. My virtual network was created, so we can see the job was done. I can go to the resource, and there's the address space. We can see that Azure is providing the DNS service by default. And then I can go ahead, configure it, add virtual machines to it, add platform services to it, and all that good stuff.
Can I just ask, how do you fold the subscription ID?
Oh, it's a plugin.
I was just curious.
It's a Chrome extension called Azure Mask.
Nice.
And really important when you write on blogs that you hide your subscription ID, or if you're doing videos or presentations, because that subscription ID is unique to you and it's used in support calls. So you don't want to be sharing your subscription IDs with customers.
Pretty cool feature. You should mention that in those slides as well, because it will be available for all people.
Okay, so covered the DNS. So network security groups. This is the foundational piece of network security in Azure. And it's not the only way we can do security, there's multiple ways, but this is the foundational piece. It's the piece that we'd say to you, anyone who works with Azure would say to you, if you're not doing this, you're committing career suicide. So you need to be doing this as your foundational piece. In fact, if you next your way through creating a virtual machine, it will give you one of these to secure that virtual machine. Now if you go to my training, you'll learn you don't want to use that one in the first place. But it's there for people who don't know what they're doing. So it gives you a level of security. We have multiple ways of doing firewalls in Azure. Your Linux or your Windows OS has a guest OS firewall. That's on, it's blocking stuff from outside. So that's a good layer to have. Then we have these network security groups that we're going to talk about in this section. This is a free feature and it gives us layer 4, so TCP UDP rules for blocking or allowing traffic. We have the web application firewall, which is a paid-for feature in Azure that operates at layer 7 for web services and web services only. We have third-party appliances, which actually run as Linux virtual machines, typically Debian Linux. So if you want to run a checkpoint firewall, a sonic wall, a WatchGuard, a Brocade, you can do that using Azure virtual machines. You have external services, Cloudflare, Encapsula, those guys. You can put those in front of your services that are running in Azure as well. And we have a new one that just went into a managed preview. It's very limited features, and it's now called the Azure Firewall. And I'll briefly mention that towards the end, because it's going to be a long time before it's something that people will be genuinely interested in once they know what it is. Network security groups are NSGs. So I'm going to probably call them NSGs for the rest of the day, and I'm talking about network security groups. These are a simple to set up system that give us hard block or allow rules for traffic. Very simple to set up, very easy to manage, very easy to get wrong. And when I say get wrong, it's usually you're blocking too much.
Is it the same? Is it one of the same stupid way like Windows firewall?
What do you mean?
No one can see through it. It goes away whenever it wants.
No, it's not that public, private type crap in the Windows firewall. I hate that. This is a very simple, it's TCP, UDP, it has no understanding of the application layer. It only understands source, destination, block, or allow. And it's stateful. We can create these policies and associate them with subnets or virtual network cards. By default, it will allow everything inside your virtual network, and it will block everything from outside your virtual network. So if someone's trying to get at your file server in the cloud, they won't be able to unless you open up SMB to the internet. At that point, you deserve to be fired after you've been flayed. It has a set of default rules to secure you by default, and then you create your user-defined rules to allow things in, or even to block things going out. It's a common question. Can I stop my VMs talking to the internet? The answer is yes. I'll explain in a moment why you need to be careful about that. The rules, define a source and destination. That can be an IP address. It can be a block of IP addresses. It can be what we refer to as a tag. I'll come back to that in a minute. We can specify what protocol, TCP, UDP, or star. The port, TCP 3389. I want to allow RDS.
That's actually a question. Do they, because I could never find document on this. When you open up a VPN protocol, right, is there any sort of any kind of protection from Azure
Yes.
side of things where there's like, you know, once you open the RDP, there's 500 people trying to get in?
Yeah,
Do they have any?
we'll have a look at that in a while. We talk about Security Center. And then we can create priorities, so we can stack rules. So we can have a policy that has a whole bunch of rules in there. The very specific rules at the top, and then the generic rules at the bottom. And then you have beneath the bottom, you have your default rules that block everything from the internet anyway. So it's typical firewalling. Specific at the top, generic at the bottom. The source and destination can be a specific IP address, it can be a CIDR block, or a range of IP addresses. And we can also specify tags. Instead, if we don't have an IP address for something, but we know that Azure knows it as a specific label, then we can use that label. So we have something called the load balancer, which we'll look at in a while. With the virtual network, traffic inside that network. Do I allow it? Do I block it?
Are tags yours or are those tags?
No, these are provided by Azure.
Other tags new?
Sorry?
Other tags new?
No.
No, okay.
No, they've been there all along.
Before we had to like find out what the IP of the load balancer was and add it back in.
No,
like
it's just
Windows
load
system
balancer.
variables, is it?
Sorry?
It's like Windows system variables where Azure knows that Azure load balancer is generally this, or who makes the tags?
Azure.
Can you have your own?
No. Though they've got something different. Which is a kind of a tag. And then we have Azure Services, which is important. So do I want to block or allow access to Azure SQL databases? Do I want to block or allow access to Azure MySQL databases? Do I want to block or allow access to Azure storage accounts? And that's where this comes in. We also have this thing called Application Security Group. It can only be managed using PowerShell at the moment. But an Application Security Group allows me to say these particular machines do the same thing, and it's kind of like creating your own tag, but it's not a tag, technically speaking. From your point of view, it might as well be a tag. Here's an example. So the dark blue rules are the system default rules. Allow stuff inside the virtual network to flow freely. Allow the load balancer to talk to machines. And block everything from outside of the virtual network. And above that, I create my user-defined rules. So here I'm saying allow HTTP, so TCP 80, from anywhere to this particular range of addresses. TCP 443, HTTPS, the same rule. Allow RDP, TCP 3389 in as well. Now, funnily enough, in the last few months, if you create that rule for TCP 3389 or TCP 22 for SSH, you'll get a little exclamation mark saying, you know what, that's probably not the best idea, because people are going to be brute forcing you.
All day long.
Oh, all day long. I had 1 week where I had 18,000 brute force attacks on one IP address.
For what service?
RDP. 18,000. Ultimate Dutch IP address. And when we get to look at Security Center later, you'll see a panel where I'm seeing lots of attacks from Russia. But Russia are our friends. It's okay. Okay?
You should just use the tag log Franco.
You know that we're the enemies now.
I know, we dodgy Germans. I mean, us dodgy Europeans.
I was referring to us as us.
Oh.
The other us.
It's all us Europeans. Us West Europeans and some East Europeans. So I can associate these NSGs with a NIC or a subnet. Best practice is you associate it with a subnet, not with a NIC. When you next your way through creating a VM, it will create a policy for the NIC of that VM. And if you have 100 VMs or 1,000 VMs, managing your firewall policies just became a shitball. That would be a nightmare. So Microsoft's recommendation is pretty simple. Create a subnet for every security domain that you need, and associate a single policy with that security domain. So, I don't know Citrix architecture, so I'm going to go RDS. If I wanted my gateway servers and my web access servers, I'd stick them here, and I would allow TCP 443 in. Then I might put my session hosts here, and allow in communications from up here. Then I might put my domain controllers down here, and I will only allow traffic from here and here to my domain controllers. And that would allow me to create a tiered architecture. Now what if I wanted to do a lift and shift, where I've got a big, flat, nasty network? Well, the reality is you're going to be lifting and shifting that big, nasty, flat network. So what you do is you go back and you use this feature called Application Security Groups. And this allows you to create almost like these tags. You can say this machine, they're domain controllers. And I'm going to create a rule in this policy to say allow traffic to these domain controllers from the other machines, but don't allow it from the internet, for example. So that allows you to have that flat network, but still have granular control. But if you're building from scratch, this is the approach to go with. Security policy per subnet. You're going to have someone who says, I need to block outbound access to the internet. So some security consultant or security expert will say, block all outbound access to the internet. Next time you go to reboot your Azure VMs, they won't boot up, because they need access to what a virtual network refers to as internet. Everything outside of the virtual network is considered internet.
And because the VM, everything's untrusted, right?
At that point, yeah. So why is that happening? Inside your VM, you probably have one or more extensions. An extension is an agent. It's Azure's term for an agent. So you might have the boot diagnostics extension. Its primary thing is to take a screenshot of the console of the VM and present it to you in the console to show you if it's blue screened or not, or if it's booted or not. But it also gives you serial access to the guest OS of the VM as well, if you need a backdoor in as the owner of that VM. You might have the performance extension. So you're pulling out SQL metrics, performance metrics, and Windows guest OS metrics or Linux guest OS metrics back out to Azure to monitor it in Azure Monitor, or to record it in Log Analytics, to run reports on it. And that data needs to get out. When Azure sees that those things can't talk to outside of the virtual network, it will stop the VMs from booting up. So what you do is you use those service tags that I talked about earlier. So what I can say is create a rule to allow access to Azure storage. And I'll use the storage tag. If my VM is running in the East US region of Azure, I will say allow outbound access to service tag of storage.eastus. Now my VM can talk to Azure Storage in East US and store its performance data and store its diagnostics data in that storage account that's running there. And then the next rule will be the one the security officer has insisted on, or as I like to call them, the insecurity officers. Deny internet. Destination internet, deny.
You allow all source on all port?
Yeah, because I don't know what the ports are. Because it's going to be multiple ports. Because there's at least 2 services in Azure Storage that are being used if you're doing diagnostic settings and boot diagnostics.
But the port are already known. There is a way to which port need to be open.
If you want to lock it down and find out what the ports are, you can probably open the support call with Microsoft to find out what the ports are.
Just to clarify, when you say the agents running on the VM, is this part of the integration stuff?
Yes, sort of, but it's not like Hyper-V integration.
But you have no control of that.
It's outbound communications from an agent to that storage account.
So
It's not the integrations that you know from Hyper-V.
But the agent on every Azure VM is there, and you cannot scrub it out.
You can. You really want it there, trust me. If you have a customer call you up going, my application is slow, you want the data to know why it's slow.
Oh, no, I mean more in a
If you don't want the extensions, you don't have to put them in.
I mean more in a security type way, so that say some customers will be concerned that if there's an interface, you have
It's an
this-
outbound interface, it's not an inbound interface.
Screenshots of the VM, like a serial screenshot.
It's only the KVM, the front, so all they're going to see is the login screen.
So there is no interface to that.
No,
from that.
there is no KVM.
And there's a doc which describes all this.
Lots. Come to my training. So I've talked about that. Never assume that a virtual network won't be connected. Always give it a unique IP address for that company or customer. Even within Azure or across Azure and AWS and Google Compute and whatever, make sure it's a unique IP address for that customer in case you need to connect that VNet to something else at a later point. And treat each subnet as a security zone. Start designing with security first. So have the security model before you start dropping in subnets.
So for the old school, this basically treat each VM as a new VLAN.
No. That would be insane.
No, because
It would be, if I have web servers, they will go into a subnet. If I have application servers, they'll go to another subnet. If I have database servers, they'll go to a subnet.
No, because
So there'll
you know,
be
there's-
3 VLANs in that case.
There's a lot of customers who, when you come in and they say, we
Oh.
have like 100 VLANs, so they want to.
Hey, if they really want to do it, they can, but that would be insane. I would say look at the application groups if it's that big flat environment.
But the VNet is more or less the next closest thing to the VLAN.
No, the subnet is.
Right?
And a VNet is an isolated environment. So if I want multiple isolated environments, I would have multiple VNets. So creating and editing these NSGs. So it's pretty simple stuff. Go to create a resource and network security group and create. It'll ask me to give it a name and where I want to store it in my resource groups. That's pretty much it to create a network security group. Now it will only give me the default rules and it hasn't been associated with anything yet, so it doesn't apply yet. So, excuse me. Once it's created, boom, I'll get one of these. And within it, it has 2 settings groups. It's got inbound security rules and outbound security rules. What do I want to block in or allow in? What do I want to block or allow out? And you can see by default, once you go through those rules there, it will by default allow everything out. And here, if you look just at the bottom 3, it will actually block everything inbound using this deny all inbound rule.
Does it has some break in case you got some ransomware which doesn't which only establish connection to the outside? Is there some
No,
preset rules which would say, you know, when we talk about getting outside?
no,
Right, so there's no.
no. And if you want that today, you need a third-party firewall appliance. Going forward with the Azure firewall, when it's ready for production, that will be the one you will use. because it will only allow outbound connections that you specifically allow. But if you wanted to prevent that, you would, like I said earlier, put in a rule that says block all outbound, and then only allow the individual things you want outbound to begin with. So you could still get that sort of effect.
But it would not prevent third-party tools from having this functionality.
No. You can, if you want to run a checkpoint firewall to do that stuff, you can do that quite happily, and Microsoft will love you to do that because it's more money for them. Even if you buy the checkpoint license directly from Checkpoint instead of the marketplace, which is the recommended way to do it. It's cheaper to buy direct than to get it through the marketplace over the long run. You're still running a Linux VM, or 2 or more Linux VMs if you want HA.
Oh no, but I mean, if you want to do it within the VM.
Yeah, you can do it. So if you bought some software application or whatever, yeah, absolutely. So I can come in and then create rules. And if you've done any firewalling at all, even Windows firewall, you'll find this easy. Define the source, so IP address, and I can bang in an IP address. Define the source port range, if there is a source port range. What the destination is, so I can say it's a particular IP address. What the port range is, whether it's star, TCP or UDP. Block it or allow it, and then give it a priority, so I order the rule within my system. Tip of the day there is don't do 1, 2, 3, 4 for your priorities. Do 100, 200, 300, 400. So if you have to add rules afterwards, in between 2 existing rules, you just say, well, I'm dropping in 150. And then it will automatically just fit between 100 and 200. So that's just normal networking and routing, good practice. I've actually got a broken rule here. So my allow HTTP, if you look at it, is denying traffic. So that's not going to be a very good web service. So I can come in here and I can say that I want to allow that, and then I can click save. Now before I do that, what I'm going to do is figure out what its IP address is. That's it there. And just to prove that it isn't working at the moment. So the deny rule is actually in effect. So that's timing out now. You guys don't see that properly. So that is now timing out there. Either that or the Wi-Fi is broken. It is E2E PC after all. And that's not working, so we will go back to here and it is set to allow, click save. That will update the security rules, so that might take 30 to 60 seconds for that to actually work. And I want to pop that in again. And eventually this will actually load. Assuming I remembered to turn on the VMs last night, which I believe I did. There we go, did actually load. So that's the VM has actually loaded. And I'll explain what's going on there when we start talking about load balancers. So that's network security groups. So that's
should we take a 10 minutes break? Yeah, take 10 minutes break.
Can you follow the rules of VM basis?
If I associate it with a NIC, what I've said is don't associate it with a NIC, associate it with a subnet. So I've got one policy there. So we've talked about networks, talked about DNS, talked about network security groups, our basic firewalling mechanism. Next thing we're going to talk about is public IP addresses. I might have some VMs or some services in Azure that I need to make available to the internet. Now, I don't have to put my VMs up on the internet. You know, the early cloud detractors would go, well, I'm not sticking my file server up on the internet where everyone can see it. Well, that's how you've designed networking in the past. Good luck to you, and good luck to your customers. We can make those things private, but we still will be using private or public IP addresses in a way. So public IP address allows us to create something called an endpoint. Some parts of Azure will actually use the phrase endpoint. When I get a public IP address, I am getting a publicly routable IP address. Now it's interesting because let's say I deploy a virtual machine in West US over in California. I might not necessarily get what's referred to as an American IP address. Because as you're probably aware, there are no free IPv4 blocks out there. There are only IPv4 blocks that are being auctioned off and sold. So if you deploy a VM in AWS, for example, you might get an IP address for a country called Eritrea, even though your VM is running in their region in Virginia. If I deploy a VM in Dublin, in Ireland, I will get a British IP address, and Ireland is not British, by the way, if you didn't know that. I love being here in Canada. So this public IP address, it can be associated with an Azure resource to make it available on the internet. That could be a VM. So when you next to create a new VM, it will get, as I mentioned earlier, a network security group of its own for its NIC. It will also get a public IP address of its own. Now, think about this. If you've set up a network for yourself, for your customer, did every server get a public IP address? No. You'll have one or more IP addresses at the edge, which you then NAT back through to your servers behind the firewall. And that's the best practice in Azure, is you'll have one or a few public IP addresses that you will NAT through to your VMs on your virtual network. And a typical NATing device is unfortunately called a load balancer. I wish they'd come up with a different name, because when you see the name load balancer, you think, oh, that's for load balancing. More people use it for NATing than for load balancing. We also have the virtual network gateway. The gateway, an important resource, it is used for private network connections. So end users who want to VPN in, and a WAN service called ExpressRoute, or site-to-site VPN. We'll talk more about that in a while. When I create one of these public IP addresses, it will be dynamic by default. So let's say I create a set of virtual machines, and they're sharing a public IP address, being NATed. If those virtual machines are running, that IP address is mine. It does not change. But if I shut all of those virtual machines down, in other words, I deallocate them, that IP address is handed back to Azure. And now when I power up the first one of those, my public IP address will be reassigned, and I will get a new public IP address. So when you're dealing with virtual machines, and you create this public IP address, best practice is check a little box to say static. No extra cost. It's the same price. It's roughly, I'm trying to think what the exchange rate is, it's roughly about $2.70 per month for that IP address. It's not going to break the bank. So for virtual machines, always set that public IP address, or PIP, to be static. Some services will require it to be dynamic, but it doesn't matter because they never shut down. Once they're created, they're running, or allocated, as Azure would refer to it. So these endpoints. What is an endpoint? From Azure's point of view, an endpoint is something that has an IP address and a DNS name. When I create one of those public IP addresses in Azure, I have the option of giving it a name. And then Microsoft will give me a Microsoft managed domain name for that IP address. Now, it's up to me if I want to use it. I can always go to my DNS zone, whether it's with GoDaddy or I'm managing it through Azure, and I can create an A record that points to that IP address. and the Microsoft managed domain name is irrelevant to me. Or if I want something and I don't need a public, like a company vanity domain name, I can just use what Microsoft gives me for free. And it's there, it's free. It's a very easy setup. So, how do I set up an IP address? Go to the Azure portal, create a resource, public IP address, create, and you think, oh, I just want an IP address, that'll be easier than setting up a firewall policy. It asks an awful lot more questions. So, what am I going to call it? That's just a management name. What SKU do I want? Basic or standard? Not much of a price difference. It's a functionality difference. Most of the time you're going to use basic. Standard, primarily it's used in something called availability zones that we'll talk about in a little while. But it can be used in some network appliances that require additional features, like SNAT or SNAT, where you could have secure NAT. You're controlling what traffic is allowed out. So by default, nothing will be allowed out in SNAT, and you have to say what traffic is allowed out, and very specifically. It can be IPv4 or IPv6. Dynamic or static. If it's VMs, set it to be static. If it's network appliances, it will be dynamic. Your idle timeout, your DNS name. So I'm creating this one in the region called East US 2. So if I called this E2EVC here, it would be e2evc.eastus2.cloudapp.azure.com. Rolls off the tongue. But as soon as I create it, I could actually resolve that domain name back to the IP address that I'll get from Azure. And that can be very useful. What subscription I want to create it in, what resource group, what location. And that'll be up and running in a matter of seconds. And then if I go back to home, and come in here, actually I have a shortcut to it.
You add DDoS protection to it?
No, the DDoS is done at the virtual network.
Okay.
So this is a pip that I've got created. So I click configuration. This is basically your configuration options. So my idle timeout, there's my IP address. It's actually up and running at the moment and it's set to static, so I can't change it. If I shut down the VMs that are using it, I could change it back to dynamic. And there is the name, AFNYNSG. Again, it just rolls off the tongue. If I go back to overview, I can copy the domain name, put it in there, and it's resolved to the load balancer that that public IP address is associated with. So that public IP address is being used to NAT the two load balanced web servers. So we'll be looking at that later on.
What network will the load balancer sit on? You know, if we're talking about like our 3-tier, will you make one network just for the load balancer to live on, and it has the links into your
It's simpler than that. The load balancer lives on the same network as the VMs.
Oh, okay, so
It's not an actual machine, so to speak.
It's the fancy.
It's a service
that with the NICs, right?
Yeah, it's a clever service that doesn't really have a network.
Okay.
But it does live in the same subnet as the VMs.
So, question. So basically, once you set up the NAT, just load balancing just comes with it. Like you don't have to do anything.
You'll see in a little while when we talk about the load balancer.
Okay.
The toughest thing about teaching Azure is ordering things, because you've got to do the basics before you do the advanced stuff. But when you're doing the basics, you've got to talk about the advanced stuff. And it just creates this awful, I've got to explain things before I explain things situation. So when I do the VM class, I think we do refer to the load balancer like twice. And we explain it before we actually ever get to do it, because we have to go so much in a circle so many times. The DDoS protection I've already talked about, so we'll skip through those slides. It's a yes or no button. It's basic or standard. And it's not even yes or no, it's just you get basic for free, it's on by default. Standard, you pay extra for the service, and it gives you machine learning to power it, and insurance in case your costs go up because of a DDoS attack. So if you're worried about DDoS attacks, go with standard. If you just want DDoS protection and you're not that stressed about it, go with basic.
You say it's at the VNet level?
That is at the VNet level, yeah. So it protects everything on the VNet. Service endpoints. So Azure has lots of different services. And last time I looked at our price file, it was something like 23,500 lines. And that was items of different sizes across different regions. So lots of duplication there. But lots and lots of different platform services. And some of these platform services that you can see listed here can be connected to a subnet. So if I create a VM and I would like it to use a database, instead of actually firing up a VM with MySQL or a VM with SQL Server, I can actually just create a database in Azure. And if all I need is a connection string, I can use those services. And that's great because Azure SQL starts at about $5–6 per month for a small database. SQL Server in a VM, you're looking at about a minimum, I think, of $270 for 4 processors. So it's a big cost difference. And normally, if a VM wants to talk to Azure SQL, it just talks to through the magic of Azure networking. So the packets leave your virtual network. By enabling these service endpoints, and that's done on the subnet, I can say I want to enable service endpoints for Azure SQL, and then I can go to my database server in Azure SQL and say I would like you to connect to this subnet. And now packets from my VMs will go through the virtual network to that database, and not through the public Azure network. And that's great for the compliance side of things. I'm not actually going to do a demo of that because that's literally a button. And Google it if you want to find where the button is. It's very easy to set up. And I am concerned about time because we have a lot of slides. So, the Virtual Network Gateway, an important appliance. It is a virtual appliance. And underneath the covers is actually 2 virtual machines running in a cluster that are managed by Microsoft. They don't say anything more than that. We don't even know what OS they're running. Probably Linux, to be quite honest. We have lots of ways that we can connect to things privately in Azure. And this gateway plays an important role in this. I can fire up a third-party firewall as a VM running in Azure. So if I want a Cisco firewall, a Riverbed appliance, a NetScaler, Citrix, I can fire up those as virtual appliances, which are Azure VMs, and can deploy them into a subnet or subnets in my virtual network. That's one way of creating external connectivity over a private network connection. Common approach, which most of you will be familiar with, is I can deploy RDS or Citrix and use that as a way of getting my end users into my applications running in Azure. And interestingly enough, RDS is going through a massive growth phase. I guess, Benny, you probably would have talked about that yesterday, RDMI and all that stuff in your session.
Yes, absolutely.
And so RDS is going through massive growth thanks to Azure. It had flat lines before that. And then all of a sudden, it'd be interesting to see what's happening organization-wise. Has it gotten better? We can't say. That's understandable. Application layer, we can also do that security, and basically I can have an SSL application. It's probably the best way from a developer's point of view, to be quite honest. But very often we have legacy systems where they have to be accessed at the network layer. And we might want to access them privately. So that means traditional network connections, end user VPNs, site-to-site VPNs, or WAN connections. And all of these are made possible using something called the Azure Virtual Network Gateway, simply referred to as the gateway. Now, before I go any further, someone is probably going to ask me, can I just fire up ORAS in a Windows box? Can you? Yes. Would it work? Possibly. Is it supported by Windows Server in Azure? Nope. Why? They won't say. I've seen them being asked dozens of times, and the question is always met with silence. So, you wanted to run direct access or that any VPN or whatever it's called in Windows Server 2016, not supported if it's running in Azure. So you have to find an alternative. But if I want end user VPN, site-to-site VPN, or a WAN connection, this gateway appliance makes that possible. As I said, under the covers, it's actually a cluster of 2 VMs that Microsoft run and manage for us. They update them as well. If you look at the logs, you will see where you have brief blips for about a second while it flips the connection over from one to the other, so they can do an A/B update or a rolling update. This thing requires a dedicated subnet in your virtual network called a gateway subnet. And you can have one gateway in your virtual network, and one gateway only. It will use a public IP address. It's a dynamic IP address only. Why dynamic? They won't say. Does it matter? No, because the gateway is always on. Once you deploy it, the only way to stop it from running is to destroy it. And you won't, because it actually takes about 45 minutes for one to be created. So you'll deploy it, you'll leave it running. It's not an exciting demo to create a gateway. Quick wizard, wait 45 minutes. And I accidentally did that once in a presentation. It wasn't great.
The dynamic, though, the DNS name still resolves, right? You just like the IP changes.
The IP changes, and well, the IP changes, the name won't resolve.
Oh, really?
Yeah, because the IP has changed.
Really? Oh, wow.
Oh, if you're using the Microsoft,
Yeah.
yeah, that'll still resolve.
So the name is still good.
Yeah. There are 2 different types of VPN. And using Microsoft language, they're referred to as policy-based or route-based. In the old Azure language, they were referred to as dynamic and static. So policy-based was static, route-based was dynamic. We don't see that language anymore. Policy-based is the one that sucks. It allows a one-to-one VPN connection. It does not support WAN connections. It does not support end-user connections. So if I create a policy-based gateway, all I get out from it is the ability to have a single site-to-site VPN connection. Why would I ever deploy one of those? Because I bought a shitty firewall for my customer site, and all it supports is policy-based VPNs. What you want is route-based. And this is capable of offering all the services. WAN connections, end user VPN connections, multiple site-to-site VPN connections coming into it. And it is our preferred option. There are different sizes of gateways. So at the lower end, we have the basic gateways. If you look at the Microsoft documentation, they will say they are for test and development purposes. When they published that document, the Azure MVPs rebelled. Because in my case, I think we have about 70% of the Azure market in Ireland on our books. We have 10 of these in total, and the rest are all these. And of the 10, I'd say probably 8 of them were accidental, because some consultant had read that this was for test and dev. Basic, if you only require up to 80 megs per second for site-to-site VPN connections or end-user VPN connections, that's fine. Now, in Ireland, 80 megs per second is considered fast. I realize we're in New York. 80 megs per second is like the speed of what? A modem? A dial-up modem here, is it? And talking to the Europeans, 80 megs per second, and they giggle at you. You go to Sweden and say 80 megs per second, they'll laugh their heads off. Germany, I think it's...
Depends on where you are.
Yeah, really? Still? I thought you all were on your gig connections.
No, absolutely not. We wish we were.
Okay.
The noose is working though. You think it
So, basic. It's okay for site-to-site VPN, end-user VPN, stuff like that. $27 per month around that. The policy-based version of it, again, 80 megs per second. Now, Microsoft say 100 megs. If you read the documents and read deep down, they'll say, yeah, it can get up to 100 megs. Expect 80 megs. Because the reality is the VMs under the covers have a single core, and it only handles so many interrupts at a time. So on good days, the sun and the moon are in the right position, you might get 100 megs. But something goes out of kilter, you'll get up to 80 megs per second. Next level up is Vpn Gw1. And this is where all the bells and whistles get turned on. This is where you start seeing radius support for end user VPN connections. On basic, it's actually based on a certificate basis. You create self-published certificates, upload them for the gateway to authenticate and for end user to authenticate. Whereas this, we can enable radius. We get WAN connectivity, a service that Microsoft calls Express Route. We get BGP routing. We have the ability to create active gateways. So if I've got multiple ISP connections from my office, I can actually create 2 resilient and aggregated VPN connections into Vpn Gw1. So if a digger tears up one fiber line, I can still go out over another fiber line or a microwave cable or microwave connection. I can easily resize from 1 to 2 and 2 to 1 without downtime, or 1 to 3. So if I only need a certain amount of speed, so up to 650 megs per second, but at times I need to get up to a gig per second, I can easily do that without having to destroy and recreate the gateway. As you can see, the price does go up once you get, and it goes up quite a bit as you move through the stack. Microsoft has a set of on-premise devices that they support. If you do a search for Azure VPN devices on Google, it's the first result. And they work with the firewall and network appliance vendors to get those vendors to write their own specific Azure configuration documents for site-to-site VPN connections. So you'll find Citrix on there, Brocade, Juniper, Palo Alto, all there. And what you'll find is there's 2 columns you care about, which are back here. Do they support policy-based VPN connections, the crappy ones that we don't want? If so, a link to the document for setting it up. We're more interested in this column. Do they support route-based VPN connections? If so, a link to the document. You'll find some companies, they'll have devices that support policy-based, and some that will only support route-based, and some that will support both. So Cisco's a mixed bag. Citrix, with the NetScaler, only supports the crappy policy-based VPN connection. In that case, I would tell you, if you have a firewall or a device that only supports the crappy policy-based VPN connection, instead of using your network appliance for the site-to-site VPN tunnel, deploy a Windows Server on-prem and enable ORAS, and configure a policy-based VPN connection through it to Azure. And that is fully supported, and there is instructions for configuring that on that page. So search for Azure VPN devices, and you'll be brought straight to that page. Not on Bing, on Google, the unofficial Azure documentation. So how do I create one? There's not much to it. Go in here, create a resource, do a search for virtual network gateway, create, and it's going to ask me for a name, so let's expand that up. So let's say it's E2E VC gateway, and what am I going to use it for? Am I going to be using it for VPN or for this WAN service called ExpressRoute that I'm going to come back to? Let's stick with VPN. Route-based or policy-based? Policy-based, my options will start shrinking. Route-based, let's stick with that. Do I want to do basic, the low-cost one for about $27 a month, up to 80 megs per second, end-user VPN connections and site-to-site VPN connections only? Or do I want to do Vpn Gw1? Let's stick with that. Because that guy can do active-active. So if I've, for example, got 2 ISP connections, maybe even I have a firewall cluster with 2 ISP connections, I can create a mesh of basically 4 VPN connections out to this gateway. And if any one component fails in the gateway, my ISPs, or my firewall cluster, I still have a connection. That's referred to as a multi-resilient VPN connection. Choose a network that I want to deploy it into, and then when I pick my network, pick my gateway, or my subnet within it. Create a public IP address, or use an existing one. And then, because I went with active-active, I can also set up my second IP address, because I'll be using 2 IP addresses in this case. Configure BGP, so I can do BGP routing with this, and then pick the region and click create. And then wait 45 minutes, because it takes 45 minutes for that appliance to be created. What will it look like? Well, if we go back to home, and I do have one here. This is my gateway, and this is my configuration for my gateway. There's not much to it. When we come to site-to-site VPN, we'll look at actually configuring VPN connectivity and point-to-site as well. So that brings us to this section, creating secure remote connections. There's 3 services that the gateway offers us. We have point-to-site VPN. This is where an end user wants to use their Mac or their Windows device to create a VPN tunnel into a virtual network through one of those gateways. With Vpn Gw1 and higher, we can get radius authentication. So I can authenticate against my domain, for example. If I don't have that, it will be certificate-based authentication. SSTP on Windows, IKV2 on Mac OS at the moment. It can also be used by a platform feature of Azure called App Services, which is basically running websites and dedicated VMs, and Microsoft looks after the VMs for me. They create them, they patch them, they update them, they secure them. And that can be useful because it allows those VMs then to connect into my virtual network. The pro of point-to-site VPN, well, pretty quick to get up and running. It allows end users who are roaming to get connectivity into my virtual network. So it's good for that. In terms of infrastructure, there's not much to it. It's just a gateway. And either radius authentication or certificate authentication. Downside, end users. Anyone here ever support end users with VPN? How pleasant is it?
Awesome. Great.
It's like every Monday morning the same people call up saying that your servers are off and that you're awful at your job. And then the first question you ask them is, did you connect the VPN? And they go, oh, so I have to do that? Yeah, you did last week as well, or yesterday as well. You still have to do that.
Oh, these people reset over the weekend.
As Matt, like when I did that most was in the hosting business, and my customers were IT people. And they used to forget every second day. It was almost clockwork. Every second day there'd be a support call. The servers are down. You did not VPN in. Like we close that ticket in 5 minutes every time. Same thing. So I don't like it. I really don't like it. In fact, you can see by the scalability, 128 simultaneous connections. Microsoft did not intend this for end users. They intended it for the server admins to have a backdoor to the virtual network. And they did not invest in this. But when they start looking at the metrics of how this stuff was being used, they realized they made a mistake. End users are using this to connect into virtual networks. So Microsoft is investing a lot in that VPN gateway for end user VPN at the moment. That Radius came late last year, and it's still in preview. Mac OS support came late last year. It's still in preview at the moment, but they're both supported. And there's more to come as well. So watch this space. I'd say they'll announce some stuff in September that will be pretty interesting. I know one of the things they're working on. So, how do I set this up? If I go back to here, here is the gateway that we looked at a moment ago. I can go to point site configuration, and I can click configure now. And because this is a Vpn Gw1, I get a few more options than I would otherwise. So I have the option of setting up SSL VPN and IPv2 VPN. I have the option of doing certificate-based authentication or radius authentication. With certificate-based authentication, I have to upload a certificate for the gateway, and then from that I'll be able to download certificates for my end users to authenticate against this. It's messy, very, very messy. So I'm going to have to create a certificate that my clients are going to trust and upload it into here. With Radius, if I've got a Radius box set up, so maybe it's Linux box doing Radius and then forwarding to my domain controllers or whatever, or Windows box doing Radius. Put in the IP address and the secret, click OK, and now if it's a domain controller at the back end doing the authentication, when my end users VPN in, they're just VPNing in with their domain credentials. So from the end user point of view, life's a bit easier. And then you download the VPN client. You can't just use the stock OS VPN client, you've got to use the Azure VPN client. So that'll make life a little bit more complicated for end users. And the last thing we want with end user VPN is complicated. And that's why you see the growth of RDS because of Azure. It's the best way of sharing out legacy applications to end users from Azure is RDS. Site-to-site VPN, quite common. Most people who work with firewalls and edge devices know how to set up their devices for site-to-site VPN. So following the guides to do it specifically for Azure is usually pretty easy for them. I never worked with Fortinet, but I downloaded the guide for setting up a VPN connection from a Fortinet firewall. Hadn't a clue what I was doing, but managed to get it up and running on the first time. Just carefully went through the guide and that Fortinet shared, and Microsoft helped write. It's affordable. It's an affordable way of creating a connection from my office or my building into an Azure virtual network. And it's stable. We do see occasional glitches, but every glitch I have seen so far has been an ISP. So I recently had two customers who were impacted by issues with an ISP called Vodafone in Ireland, and it was in one specific area in Dublin City. And we weren't helped by how Vodafone told customers about the problem. One customer was told, listen, we understand you're having problems with your VPN connection to Azure. It's actually our fault, we're deploying a fix. We thought, okay, good on you, Vodafone. Technical things happen, and you tell the customer, we're fixing it, it's our fault. People understand that. The other customer was told, oh, Azure's broken. And that led to 2 weeks of support calls. Now, we were the distributor in both cases, so we were dealing with Microsoft partners in both cases. And because of the first one, we were able to go to the second one and say, listen, that stuff that Vodafone are telling you, that's BS. It's actually Vodafone's problem. You can talk to anyone who's using Azure in Dublin right now. The people who are not using Vodafone are fine. The people who are on Vodafone are stuffed. I've got a connection going out to a different ISP. We haven't had a single glitch in 4 years.
In general, their backbone or?
It was actually in the local area in Dublin. They rolled out some sort of configuration change to routers or something, and it broke VPN connections, and only VPN connections. Everything else was fine. And it was only VPN connections to Azure.
Maybe they put the packet analyzers.
Quite possibly. They often do stuff without, like we're convinced they have transparent proxies, but they won't admit to it. We have another service called ExpressRoute. Oh, I'm in America. ExpressRoute. A router is a network appliance here. In the rest of the world, it is a woodworking device. We have routers. You can't spell and you can't pronounce words. Actually, I prefer your spelling, to be quite honest. It makes sense. Ours is color. You've got color. So, ExpressRoute is a way of having a private WAN connection to an Azure virtual network. Cool service. Main features for this are you get an end-to-end SLA from your ISP. With a VPN connection, you can't, because that VPN connection could be bouncing all over the place. Not just from your ISP straight into Azure. It could be going from your ISP to another ISP to another ISP and then to Azure. Whereas with a WAN connection, this is through an ISP that is a direct peered partner with Azure. So you have a direct connection through your ISP straight into your Azure virtual network with an SLA on the gateway from Microsoft and on your WAN connection from your ISP. And you can get very high bandwidth and very low latency from this. Microsoft are seeing very commonly here in the US customers getting between 2 and 4 millisecond latency on these WAN connections. You're talking about speeds that are good enough for iSCSI. So that makes life interesting and makes storage interesting. You can route all of your Azure traffic, not just your virtual network traffic, but all of your Azure traffic through ExpressRoute. You may have heard you can route Office 365 through ExpressRoute. Read the small print. Microsoft will not enable that unless you can prove you have a legal requirement for private Office 365 access. If you have a legal requirement, then your account manager can request that to be turned on. If you cannot prove it, they will not turn it on.
But if you did turn it on, aren't you going to pay for that traffic? Just like what we talked about? Like,
ExpressRoute has two elements of pricing. There's the ISP piece, which I'll talk about in a second. Microsoft have two ways you can do it. It's up to you when you deploy it. You can pay for bandwidth. So I want a certain tunnel, and it doesn't matter how much I use it. Or you can pay, or you can pay per gig.
oh, okay. Per month too, right?
Yeah.
Okay.
But if you're an enterprise agreement, you pay up front. So it's no longer really OpEx, it's CapEx without any capital. Cons, it's expensive. So here's my story on ExpressRoute. I'm at the MVP Summit 3-4 years ago, and there's a guy called Corey Sanders, very senior in the Azure world, and he's doing a talk in a theater in Building 33, probably 500 people in the room. And I'm sitting in the 10th row. It's a cool theater, big curved. It's like a proper theater here at Broadway, but everyone's got desks because it's Microsoft, and no Microsoft people can go into a meeting without their laptop open, bashing away on the keyboard. So I'm sitting there, with my laptop open, and I'm watching my email from work. And Corey is talking about all the new things that have come in Azure in the last year. He goes, oh, ExpressRoute, fantastic. Our best partner at ExpressRoute, our best ISP partner, is a company called British Telecom. They're global, they're amazing, they're doing such great stuff for us with ExpressRoute, all around the world. Right then, it was like karma. It was the universe was listening. I got an email from one of my customers, a Microsoft partner in Northern Ireland, who at the time was British Telecom's Partner of the Year for Northern Ireland. And it went, hi Aidan, just had a call with BT. We've asked them for pricing on ExpressRoute, and they said to us, what's an Azure?
Sounds like BT, right?
So my hand goes up while Corey's extolling the virtues of British Telecom. Sorry, Corey, I just have an email now from British Telecom Partner of the Year in Northern Ireland, and the response he got from BT, literally just now, was what's in Azure. So Corey says, right, here's my email address, email me, I'll get back to you as soon as I'm done on stage. So I emailed him. Half an hour after he's gotten off stage, the emails start flowing. So he emails his underlings, they email their equivalents in BT, and I see the emails going back and forth. And then about an hour later, I get an email back from the partner. He's like, hey Aidan, don't know how you did it, just got pricing for ExpressRoute from BT, we're going to go with site-to-site VPN. Too expensive.
Not something like $5,000, isn't it?
It's the ISP charge. That's the big piece. It's the ISP. If you've got an MPLS network already, if you've got a tail into one of the hosting companies or the data center companies who have this already, then you've already paid for the expensive piece. But if you've got to go out and buy an MPLS network with Colt or BT or any of the dozens of companies that have partnered up with Microsoft, that's expensive. If you only need a small number of connections, site-to-site VPN is probably the way to go. If you've got a retail network across the US, you've no choice. You've got to do an MPLS network.
Have you tried Citrix's Gw1? Because Citrix is selling like with replacement costs.
Is that their software-defined WAN?
Yeah.
There's something just launched in Azure. We'll talk about it later. Called Azure WAN.
SD1?
No, it's an Azure solution that will integrate into software-defined devices.
Because Citrix is trying to sell SD1 from Facebook about a year ago, and their selling position is it's cheaper than Expressroute and it's going on more systems.
Well, the problem is, are you going to have an SLA on your network connection, end to end? That's the main thing of ExpressRoute, is that you will have an SLA from your IP address all the way through to the Azure gateway. And if you don't have a WAN connection, you won't ever get that SLA. Citrix can give you something like a WAN that simulates a WAN. In the end, it's just lots of VPN connections. So if there's a glitch in a router in the wrong place, like I had a customer who was literally 1 mile away from the data center in Dublin, who said we were offline. The problem was there was a router failure in Germany, and their ISP happened to route, 1,000 kilometers through Germany, or 800 miles through Germany, back to Dublin again. And it's just the weirdness of the way the internet routes. You fast network speed, dodgy router admins apparently. I've talked about this already. So if you have multiple ISPs, you can create multiple connections into the gateway appliance. So I can have a firewall cluster, I can have a single firewall, I can have a firewall cluster again, I can have, in this case, 2 ISPs, in this case, 1 ISP, in this case, 2 ISPs, and I have 4 VPN connections going out into Azure. It's the same price as one VPN connection, because in the end, I'm paying for 1 gateway appliance, which under the covers is actually 2 VMs.
Sort of a vague question. We're trying to manage the world without SIPs growth. It's set to do file shares, all the time. It's still obviously, but a lot of you're mapping to an endpoint and copying something over. I guess various packaging mechanisms use SIPs, I believe. You can actually administrator share, et cetera, et cetera. Does anybody do SIPs over reliability over gateways, over the any?
Well, you can do
This is a vague question.
like file shares over a site-to-site VPN connection.
Right.
Yeah, you can. I have customers who would do it. I wouldn't recommend it, but yeah, you could do it, and it'll be better with branch cache or Riverbed or something like that, because the performance will be better. Because in the end, it's latency is going to be the issue.
Like a hybrid cloud, and you have some stuff like Azure.
Yep.
Does that basically mean ExpressRoute is a very good idea?
If you can afford it, and you need the SLA, then yeah. But every single one of my customers is using site-to-site VPN.
we price it, we are obviously
Like, if you can afford it, if it's justifiable for the SLA, I'd say go for it. But if you can't afford it, if you can't justify the SLA on that end-to-end connection, site-to-site VPN is still very stable. If you happen to have 2 ISP connections, you can make it even more stable using this configuration here.
What do you mean by
Because they also.
That's a Ask Microsoft question. I don't know.
There's something that's so robust.
What I'll tell you is an awful lot of the time, Microsoft has an SLA, but the actual uptime is better than the SLA. So I doubt there are very many of my customers who qualify for the virtual machine SLAs. They don't meet the requirements, but their uptime is still better than the SLAs. And we had a recent storage glitch in one room in Dublin about a month ago. And it was a weird situation where the temperature got too hot. It doesn't happen very often in Ireland.
Oh yeah, that's where all the discs died, isn't it?
Shh, you're not allowed to say that.
There are no discs.
You're not allowed to talk about that.
And the second layer failed too.
You're not allowed to talk about that. It's under NDA if you know that.
It's on the website.
Is it?
Yeah, statusazure.com.
Okay. They had an environmental sensor failure when the temperature, in particular the humidity, rose, and a lot of equipment failed. And a lot of storage and networking equipment actually failed in one row in one room. Now imagine one room has 55,000 physical servers in it.
And that was within 20 minutes. So the aircon failed for 20 minutes, bang, most of the storage died.
So, not most. When you know how many disks are in one row, it's more than what actually, way more than what actually failed. But they had a substantial failure. Now, it actually caused us downtime. Both of our domain controllers that were running in Azure were down. But we had them there for disaster recovery reasons, so it didn't actually affect us. But we saw them down. And they were down for several hours. And I thought about it, I was like, well, first reaction is that's pretty crappy. My machines have been down for several hours. But if I thought about what if that happened on-prem? What if I'd had a SAN failure? Because contrary to a lot of myth, SANs fail. The reason Microsoft rewrote Exchange in 2007 or 2010 to deal with use internal disks rather than SAN disks was because Microsoft's Exchange cluster in Europe, actually was hosted in Dublin, had a SAN failure. And they realized, you know what, spending all that money on SAN was a waste of time. Use cheap internal disks instead. And I thought to myself, well, if I'd had a SAN failure, how quickly would I have recovered from that? If I'd had a SAN failure, network and device failure, and an aircon failure, how quickly would I recover from all that? If I had to replace a large percentage of the disks in my SAN, do I think my local Dell or HPE subsidiary would have that quantity of disks sitting on a shelf? They're set up to replace a small number of disks in a short amount of time, in your 4 hours. Not to replace several trays worth of disks. So that was probably a day or two of downtime if it was on-prem. In the cloud, they got most of the customers back in a couple of hours. So that's the way I explained it to my customers. Like, think of it as a massive aircon and disk and networking failure. How quickly would you have fixed that on your customer site?
But there's another side of that. When you talk to the customers and when you sell them that, you promise them the cloud is this beautiful thing you can never see. And they see cloud never fails. And then you explain them the reason I know
IT fails.
No, but you told
yeah,
them have to.
this comes after this whole cloud BS. You know, that they say we are always available, you do this, and this, and it's all there. The reason I know about this case is because massively affected the customer. And it was just not a matter of, and they actually put a description of what happened. When you read the description, you just think, wow. So
It was actually just one row in one room.
Which affected all the customers.
Yeah, but overall, one row, one room in one of 11 buildings.
that affected for how long?
Some customers were affected for 6 hours,
Exactly.
but most were affected for only 2 or 3 hours.
I'm just saying, that there's a.
But as I
underlying-
said, if it had been an on-premise equivalent failure, those customers would have been offline for days or a week.
Yeah, but that's what you
You're
sold.
comfortable with
And
on-premise.
if they had been really concerned about that and wanted the higher levels, they would have not just done, oh, I'll just do the small cheap VMs and this, that, and the other. They would have also said, you know what, I'm going to spread my service across multiple regions. Or with the new feature in Azure, which we'll talk about later in the slides, which is I would leverage availability zones, so I'd spread my stuff across multiple buildings in the same region. I wouldn't have both my domain controllers in the same building. I'd have my 2 domain controllers in 2 different buildings.
Like we said, when you're on-prem, you're building business continuity, you're doing that across multiple data centers. Now a lot of companies, they try to lift and shift into the cloud, but it gets very expensive very quickly when you try to do multiple regions and try to do multiple data centers.
But with the new functionality with
in the cloud.
availability zones, there's not much of a cost difference.
What?
The new features availability zones.
Yeah, well, the availability zone is one way to do it, right? But if you were trying to do like a US East and US West, or one in another country, it gets to be very
But
expensive very quickly.
were they going to do it on-prem in the first place?
What?
Were they going to do it on-prem in the first place? If I was building a VMware cluster right now, where does it sit? One building.
No, it's just, you're
It's
correct.
if they've just deployed into one region in Azure, they've just duplicated what they would have done on-prem.
Yeah, that's
Anyway, let's move on. That's a whole other argument. We're talking about networking.
okay.
We can talk about that for
What do you mean by
days.
TCP, E2B flow affinity?
Yes. Don't ask me. I have no
Don't
idea.
ask
I have no idea. It works. That's all I can say. It's going to come down to how your firewalls handle it. So, how do I set up a site-to-site VPN? Main complexity is actually configuring your firewall, to be quite honest. The instructions for setting it up. And if you deal with a particular brand of firewall, that's probably easy for you. You create your gateway. And you wait 45 minutes for it to be deployed by Azure. Then you're going to create something in Azure called a local network gateway. It is a description of what's down here in your site. So the public IP address of your firewall that the VPN connection will come from, and a listing of your network addresses on your office network. Simple if it's a small business, a bit more complex if it's a larger business. Then on-prem, you'll follow the instructions for your firewall, for your network appliance, and you'll create a definition for your VPN connection to here. So you'll need the public IP address of your gateway and the network address of your virtual network. And you'll create a shared key secret, so a long random string, not Aegon Targaryen or Dragons Are Cool or anything like that. The amount of people I know who are using Aegon Targaryen as their VM password in Azure is daft. And they think, oh, I'll change the O to 0. Hackers don't know that. Idiots. Right, so now I have a shared key secret and a local network gateway. I will combine those to create a VPN connection. So the VPN connection is basically selecting this guy, copying and pasting my shared key secret. And if I have my firewall console open, almost immediately I will see a VPN connection. If I have my Azure portal open, it could be 5 or 10 minutes before it shows me the VPN connection. Because the Azure portal is not sitting there going, are you there, are you there, are you there, are you there? It's going, dude, you there yet? Right, see you in a while. And that's how the Azure portal talks to the back end. So it could be a while before it sees the VPN connection that was actually there, almost immediately. So that's the rookie mistake, to sit there at the Azure portal pressing F5. Just monitor your firewall console, it'll show you the VPN connection almost immediately. So, create a resource, and we'll do a search for local network gateway. Click create. Give it a name. So what are we in TKP is it called? IP address, let's say it's 128.707.1.56. What's the local address space? Let's say it's 192.168.0./24. And let's say we've also got 172.16.2.3 /2.0/16. Well, that's not working.
One more dot 0. 172.16.2.0.
/ There we go. I could probably put in a comma or something. And I can configure BGP settings if I've configured BGP on my gateway in the first place. And what resource group am I going to drop it into? Let's drop it into well, anywhere at all, really. You can get reminded afterwards. In my NSG, and click create. And it's given out to me because that's an invalid address. That's what you get for right 208.67.222.222. That's a valid address anyway. And click create. So that's going off and being created. And then after that, we will create a VPN connection or a connection. Create. And that'll ask me, what sort of connection are you trying to create? So in this case, we are doing a site-to-site VPN connection. And we just drop it into a resource group. And then when that's created, I'll take the shared key secret from my on-premise firewall, paste it into this, and then I will select the local network connection that I just created. And a few seconds afterwards, I have a VPN connection across the internet from my on-premise firewall into this virtual network. So a pretty complex thing done from the Azure point of view with two blades. Let's say I've got a web application, like an RDS gateway, RDS web, or just a web server. How do I present that to the internet? Well, I'm going to be using a public IP address. If I've created that virtual machine just going next through the Azure portal, I mentioned earlier that the NIC of the virtual machine will get its own IP address on the internet. So the NIC will have a private IP address on the virtual network and a public IP address on the internet. And then I could configure my network security group on the virtual network to say, or on the NIC, to say allow TCP/80 3389 from the internet through that public IP address in the virtual machine. Great. Now I have RDP straight into my virtual machine. But as you can see there, I've got 4 virtual machines, each with a public IP address. And earlier I asked you if that was a good idea. And you said no, because you wouldn't do that on-prem. And in Azure, you shouldn't do that either. What I find is people who are new to Azure, or who haven't learned how to do Azure properly, will create all their VMs with public IP addresses and create a mess for managing and securing and auditing and documenting. So setting this up is easy, but it's a nightmare to own. Instead, what you want to do is, if these 4 virtual machines were going to be in the same application, or same service, or collection of services, I'd give them a single public IP address and map that IP address to the services on those machines, or load balance that IP address to the services on those machines. So Don't do the next thing in the Azure portal. Be a bit more clever about it. Plan out what you're doing. And reduce the number of public IP addresses and entry points into the virtual network. The appliance you're going to use for this is the Azure Load Balancer. At its entry point, the basic load balancer, which is what you will use most of the time, is a free appliance. There is a standard version of it, which there's a cost to. It's a very complicated cost that I am not going to try estimating for anybody, because it's based on numbers of rules and numbers of amount of traffic processed by each of those rules and stuff like that, which will be very hard to estimate. But this basic load balancer is a simple thing. It will have one public IP address, and it is used for one of two things, or even both. It can be used to NAT services through to individual machines. So if I wanted to publish SSH or RDP to each of my virtual machines, I can do that through a single IP address. Or if I had a web service and I wanted very simple layer 4 load balancing for that web service, I can do that through this load balancer. It doesn't have to be a web service. Common scenario where you see this load balancer is where you have a firewall cluster. So maybe I deploy a pair of checkpoints as virtual appliances, which are VMs. And I'll put this load balancer in front of the checkpoint appliances. So the internet sees one IP address, but behind that IP address, I have 2, 3, 4 checkpoint firewalls processing my data and securing it. There's two ways we can use the load balancer. The first is it's going to be associated with a public IP address. So something is coming from the internet into my virtual machines. These virtual machines will be in something called an availability set. In VMware and Hyper-V, you know that as anti-affinity. Spreads the virtual machines around an Azure Hyper-V cluster. So different fault domains if there's a hardware fault, different update domains if Microsoft is rolling out updates to their Hyper-V hosts. Each of the virtual machines has a NIC with a private IP address. And we have the internet. We will deploy something called the load balancer. Basic one is free. It will require a public IP address, roughly $2.70 a month. So that's the cost of my basic load balancer, roughly $2.70 a month. And I can create NAT roles. So I can say, anytime some traffic comes into TCP 50004 on that IP address, forward it to TCP 3389 on that NIC, virtual machines NIC. So now if I want to RDP to that machine, open up the RDP tool, put in the name of the IP address, colon, 50004, and click connect. Or if you click the connect button in the Azure portal, it will actually download the RDP file with that configuration automatically. Just automatic. I can create another NAT rule to say anything comes in on TCP 50005 on that IP address, forward it to the NIC of that virtual machine. And now I've got RDP connectivity to both my virtual machines through a single IP address. So I've reduced my entry points into my network. I've reduced my attack surfaces.
Oh, the scanner will still enable both of them.
Yeah, it will. And we will restrict it further down later. Now what you can do is, on my network security group, I could actually say allow TCP 3389 into here, but only allow it in from my public IP address. And that would be common enough to see, where people will say, I will allow it in from this office, that office, and this service provider who manages those machines for me. But we can also use the load balance. Let's say those two machines are web servers, and I want to do some basic layer 4 load balancing. I can define in the load balancer a back-end pool. I can select machines from this availability set and say these machines are doing the same thing. Then I create a probe. The probe's job is test to see if the machines are up and running. If I configure the probe for HTTP, I can actually tell it what URL to test. So if I test TCP 80, IIS might be up and running, but the application pool might have crashed. or the code might be bad on the web application, not that developers ever publish bad code. The probe can be told, actually test this particular URL on the site, and if that comes back healthy, that machine is healthy. If it comes back with an error, that machine should not be load balanced. And then create a load balancing rule. What port coming in should be spread across the healthy machines in this back-end pool. Now that availability sets feature, its primary purpose is actually to get an SLA. So 99.95% SLA for what we call a valid availability set. A pair of domain controllers that I want to spread around the Azure cluster. A pair of web servers that I want to load balance and spread around an Azure cluster. Most of the time I see availability sets, it's people who actually want the NAT feature of the load balancer. So in the small business world, that might be a machine that's running as a domain controller on a file server, and that might be an RDP box. And they put them in the availability set, not for the SLA, but to actually be able to share that public IP address through the load balancer. And they're using it only for NAT.
How much is the price-wise or money-wise? How much does it increase the price compared to others?
It doesn't. It's a matter of having VM. If you want a valid availability set for the SLA, it's a matter of having duplicate VMs. But the availability set doesn't cost anything, because you're using the same amount of resources.
There are two, the main and the web.
No, they're the update domain and fault domain, and the availability set spreads the machines across both. So the gotcha with the basic load balancer is that, to keep it simple, it really only deals with one public IP address at a time, and only deals with one availability set at a time. It doesn't understand more complex situations where I might say I have one IP address and I would like to deal with lots of individual virtual machines and lots of different availability sets. It doesn't deal with that situation. So if I want that more complex situation, I need to step up from the free or basic load balancer to what's referred to as the standard load balancer. And there's a cost to having the standard load balancer, which is extremely complicated to figure out. It's one of those get the bill first time and expect that's what it's going to cost going forward. I can also configure the load balancer for internal usage. So let's say I have a pair of web servers I'm going to deploy in Azure, but I'm only going to access them over a WAN connection or a VPN connection. They won't have a public IP address. They're going to have an IP address on my virtual network. And that's what I will connect to when I want to access that application. So we start off with the same thing. My virtual machine's connected to a subnet on a virtual network. I'll deploy the load balancer. But when I deploy the load balancer, I will say it's going to get an IP address from this subnet. And that's the only difference. Everything else is the same. Back-end pool, probe, load balance rule. So now, anytime I want to talk to that web application, I will just talk to this IP address from the subnet. And that's used quite a bit in some of the more interesting architectures. Like this one. This is an Azure reference architecture. If you want to see that, do a search for Azure reference architectures in Google, and you'll find a whole bunch of these. And they're kind of cool to learn about architecture in Azure. They'll show you best practice, they'll show you variations on the different best practices. And if you follow the right links, they used to just give you a button. It was really handy. But if you follow the right links, they will give you the JSON files or the ARM templates, the cookie cutters for deploying this. So you can go to your boss or your customer and say, I'm going to deploy this for you. Don't worry, it's going to take me a week. It's actually going to take you, of your time, about 3 minutes. Now the JSON templates might run for 20 minutes or an hour each. That one I think is actually made up from 2 or 3 different templates. They run at about 15 minutes each. But you just put your feet up. You've shown your boss what you're deploying. That looks complicated. It's going to take time to deploy and configure and secure and everything. So your boss will take your word. It's going to take a week. You're playing Doom or something, or golfing or whatever you're into. So here we see a load balancer, public load balancer with a public IP address, and it's load balancing 3 web servers in one subnet with a network security group. The network security group is associated with the subnet and saying, allow in TCP/80, allow in TCP/443 into this subnet, into that IP address range. And then I have another subnet with my application layer. And it has network security group that says, allow in traffic from this IP address range. And instead of these machines talking to individual machines back here, they're just talking to a single IP address on this subnet owned by this load balancer. And then back behind that, I have a database cluster. SQL always on. Pair of database servers in a cluster presented to this network, to a network security group. Again, an IP address on an internal load balancer. And they've been clever here. It took them 2 years to figure this out. But Windows Server 2016, when you're doing your cluster, can actually use an Azure storage account for a quorum. And that won't even cost $0.01 per month for that storage account, because all that's stored in it is a single file with an integer that increments every minute.
And this load balancer, is it how smart is it? I mean, can it do traffic packets, whatever? Is there
It's very, very simple. It understands how to route TCP or UDP, and that's it.
DNS.
It doesn't understand the application layer at all.
Do they have smart load balancers?
Yes, they do.
And how much do they cost?
Starts at about $50, $60 per month for one instance and goes up. We actually look at it in a little while. And then from the security RDP side of things, they've actually created a jump box. So they're not RDPing directly into these machines. They're not natching these machines for RDP or SSH. Instead, they have a dedicated subnet with a VM in here, probably a very low spec VM like a B series or something. It'll probably cost maybe $10, $20 a month, depending on what spec you deploy. Network security group that says, okay, this machine has a public IP address on the internet directly, and we're allowing in SSH or RDP from the IP address of the company, or the IP addresses of the company, allowing the ops guys and the admins to log into here, and then they can SSH and RDP to the rest of the network. And the NSGs of these subnets will allow that traffic only from this subnet. So that gives you that bit extra layer of security, and we can take it further. We'll see in a little while. So, how do we set that stuff up? What are we doing on time? Not so good. So I'm going to have to be fast here. And the load balancer is not fast to set up. So, I've actually deployed a load balancer. It's a very simple wizard to deploy a load balancer because it doesn't actually configure anything. It just gives you a name and either create or select a public IP address. And set that IP address to be static if it's a public IP address, or an internal one. And then in here, I can create NAT rules. Now I've already got a couple of NAT rules, but I'll show you how they were created. I can go to add and give it a name. So call it demo. Select my front-end IP address. That's the public IP address of my load balancer. What service would I like to NAT? Let's say it's FTP. And it automatically knows TCP/21 is the public IP address. But I might go, oh, I'm going to be clever. I'm not going to publish my FTP out to the internet as 21. What I'm going to do is I'm going to make it 2100. And then I will select my virtual machine. Let's say it's that machine. And select its NIC that I want to do it to. And then I will port translate or do port mapping. So I can say anything that comes into the public IP address on TCP 2100 will actually be sent to the NIC on TCP 21. So now if I FTP to that public IP address on port 2100, I'm actually reaching the FTP service on that machine on TCP 21. Click OK, and it takes about 30 seconds for that to save, and then it'll be up and running. And that's a NAT rule. And I've got those set up for RDP here. So we can see that this machine has a NAT rule for anything coming in on the public IP address on TCP 50001 will be routed to 3389 on that NIC, on that VM. And once I do that, I can actually go to that VM click connect, and over here the connect screen will appear, and you can see that automatically it's setting me up to RDP in on that IP address, TCP 50001, download the RDP file, and depending which browser I open, I either have to click the RDP file or it'll automatically open. So I can download the RDP file, click that, click connect, and that's it. There's the login screen to connect to RDP on that machine. So that's NAT rules. They're pretty simple. Simpler than setting them up on a firewall, I think. And the firewall I work with, which is WatchGuard, it's pretty simple for configuration by firewall standards, but I find this is a lot easier. Now, let's go back to the load balancer and look at load balancing. So we can create a back-end pool. Actually, it'll take too long to do it, so what I'm going to do is jump to one that's already configured. So here it is. Back-end pools. The back-end pool basically is just select the VM and select the NIC from the VM. Then select another VM and select the NIC of that VM. Click Save, wait about 60 seconds, and the pool is created. The wait about 60 seconds is why I'm not going to do a live demo of that. It's a pretty boring demo to wait for. Then I go to the health probe. And the health probe is basically testing the machines on a specific port or service to see if they're up and running. So in this case, I've said test HTTP. And I'm just testing the root URL. If it was a real server, I would actually say, you know what, test default the HTM. And if that responds, that machine is healthy. If I get an error for that page loading, that machine is not healthy. And that's a better test. I could have also said, test TCP. So if this was a SQL cluster, test TCP 1433. If that's responding, that machine is healthy. Send traffic to it. And that's the probe. And then you create the load balancing rule. So you go here, add, give it a name, pick the public IP address, TCP or UDP, what port, what backend port, if you wanted to obscure it. So I could have gone, you know what, let's go with 8088, and then NAT that back to 433. Pick my backend pool that I created earlier, pick my probe, my session persistence. How do I want to keep sending a particular client to the same machine repeatedly in case they have a conversation going on or a transaction? It's a very simple system, client IP or client IP and protocol. This does not understand cookies. There's another load balancer in Azure that does. And if I'm doing SQL always on, I would set that to enabled. And then click save. And at that point, you have a load balance environment. And that particular load balancer is the one we've been connecting to here. So that's that particular load balancer. If I hit this enough times, eventually, well, actually, reality is I'm not going to see it switch to a different VM because it's just me doing that connection. If we had 1,000 connections coming in it, we might see 500 going to one server, 500 going to the other. But with me just going connect, 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 it's just not fast enough to stress the load balancer to load balance me across the machines. But if one was to power down or stop, I would automatically be routed to the other within the probe's timeout for failure. Right, availability zones. So, as the debate was going on earlier about VMs and uptime and all that stuff, one way of getting around that is saying, okay, I replicate my machines to another place, or I duplicate my machines to another place. Because those are your options. You can replicate for failing over, or you can have a duplicate, and you either forward traffic from one to the other, or you load balance between the two duplicates. Depends on your application architecture. But there's another option, which is availability zones. What you're looking at there is a satellite photo from Google Maps of Azure North Europe. This building here, often shown in Microsoft's videos about their regions and data centers, is referred to as DB3. That's DB4, that's DB5. DB5 is pretty appropriate because there's a building here that's pretty tall called the Empire State Building. DB5, if you were to take the Empire State Building and lay it on its side, is the same length as DB5. And who says Hyper-V doesn't scale? DB6, DB7, and they're deploying more here. They're also going to be building a power station here if they can get permission to take this land. The land is actually used for a park. They measured the usage of that park last year. 5 people use it. The park is set up to play foot golf. So a football and you kick it into a hole. 5 people used it last year. So they're trying to buy the land off the local government, the local council. And the council's kind of going, no, I don't think we're going to sell it to you because it's a public amenity. But 5 people used it last year because there's actually no housing. The nearest housing to there is about 2 miles away. So it's not exactly a convenient location for people. So if I deploy a whole bunch of VMs, they might appear in this building. I think it's actually this building that had the outage last month. And they might all appear in one cluster, in one building. So one row of servers, one cluster, which is about 1,000 physical servers in a Hyper-V cluster in Azure. So well more than the 64 we can do on-prem. And if that cluster did have an environmental issue, all my VMs would go offline. So what if I could say to Azure, you know what, put some VMs here, put some VMs here, and put some VMs here. So if one building or one room has a problem, my VMs stay up and running. So I could have one domain controller here, another domain controller here, a web server here, a web server here, and a web server here. Now, if one of my web servers goes offline, I still have 66% of my capacity. If one of my domain controllers goes offline, I still have a domain controller. So my domain is online. And that's a service that is currently rolling out in Azure called Availability Zones. It is live in the newest active region, which is France Central. And it is rolling out in preview in a number of other regions at the moment. And their goal is to have that up and running in every region across the world. It does require them to do an awful lot of infrastructure investment in the existing buildings that wasn't originally planned for, but it is rolling out. If I was going to have 2 or 3 web servers, what's the cost difference? Not much really. To be able to do it, I'm going to have some networking impact. The number of VMs won't change, so the cost of the VMs won't change. I'm going to need a standard public IP address, not a basic IP address. The standard public IP address offers a few extra features. So it does SNAT, so controlling outbound access by default. Nothing's allowed out by default. I have to create rules to allow that outbound traffic. It's zone redundant. So those collections of physical buildings are referred to as zones. And if there's 3 zones in an Azure region, that IP address lives across the 3 zones automatically. And it's only static as well. And it's like 10 or 20 cents more expensive than the basic IP address. Then I use the standard load balancer, which lives across those multiple zones. And the basic load balancer that I've talked about so far is free. It just requires a public IP address. The standard load balancer is not free. It has a very complex pricing system. So much so that I don't actually understand it. It takes a lot for me not to understand Azure pricing, because it's what I do all day. It supports very large back-end pools, up to 1,000 virtual machines in a single pool, for something called a scale set. Supports lots of NAT rules. I have never had a problem with the number of NAT rules supported by a load balancer. So I'd be interested to see the customers who did have the issues. Cross availability zone load balancing. So if I have those 3 servers in 3 different buildings or 3 zones, I can load balance them as a single entity. It understands something called HA ports. So let's say I have 2 checkpoint firewalls behind a standard load balancer. I can have those running in an active configuration. It understands networking flows. So it will send the same conversation through the same firewall behind it to keep a consistent conversational view for that firewall. The basic load balancer can sit in front of 2 checkpoint firewalls or 2 Brocade firewalls or whatever, but they would have to be in an active-passive configuration. Whereas this can do active-active. By default, it requires explicit SNAT connections. In other words, you have to specify what outbound traffic is allowed. It won't be allowed otherwise. And the IP address lives across multiple zones. Also, I can have zone resilient VPN gateways. And these are additional specs to the ones we looked at earlier. So not the basic Vpn Gw1, Vpn Gw2, but these are Vpn Gw1 AZ if I want a VPN, or 2 AZ or 3 AZ. If I wanted express route, it'll be these guys. And these are higher cost than the other ones we were looking at earlier. What they do here is they spread that across 2 of the 3 zones. So if one zone has a problem, one of your appliance's cluster nodes stays up and running and keeps your connections up and running. So I was just asked when we were talking about load balancing about whether I could set up a load balancer in Azure to be more application aware, knowing more than just TCP and UDP. If I want that, the Azure service I can deploy is a web application gateway. Now another alternative is deploy NetScaler, or Kemp, or if you have the budget, F5. But Microsoft does provide the web application gateway. Now this guy does offer more than the load balancer. It probably will be used in addition to the load balancer. We'll see that when we look at some architecture stuff. But this guy only understands HTTP and HTTPS. If you need an application layer load balancer that understands other protocols, like ICA for example, you will need a different load balancer, a third-party one. You'll probably go NetScaler. The WAG, or Web Application Gateway, I do have customers using it. Once it's up and running, it's a beauty. Getting it configured is a freaking nightmare. Because when you click save, you can be sitting there 3 minutes while that rule update happens. And there's not a thing you can do. In addition, you've got to wait for that rule update. You can't change anything else on it. It gets locked while that rule update is happening. It's very, very slow to configure. But then once it's configured, that's it. it's stable, it works, and it does the job. It is paid for. Under the covers there is a virtual machine running, and in production you will need 2 instances. So if an instance costs, let's say $60, to run a production workload you would be paying $120 per month. Or maybe you might have 3 or 4 instances to get more bandwidth supported by it. It does lots and lots of different things. Yes, it does basic HTTP load balancing, testing some back-end machines, understanding HTTP and HTTPS, forwarding traffic to them. It does things like cookie-based affinity, so we can have session persistence based at the application layer. It can do SSL offload. I can put my SSL certificates on the application gateway instead of my web servers. So I can serve my CPU and my web servers for my actual web traffic, my web application. It can do URL-based content redirection. That's based on something called a listener. So this web application gateway will have a single public IP address. And on the application gateway, I can create listeners, one for each domain that it is going to service on the back end. So I can have joelway.com and cloudmechanics.com serviced back here. So I can have joelway.com here, cloudmechanics.com here, and a single IP address here. I'll create a listener for joelway.com and a listener for cloudmechanics.com. And the listener's job is any traffic for that URL comes to me, there's a set of rules associated with me, I direct that traffic to a particular place. So I can have dedicated servers for that, or even shared servers if I want. That allows you to also do content redirection. So let's say this entire farm here was cloudmechanics.com. I can have all my static content going here, all my multimedia content going here based on the URL redirection. And lots more stuff we can do as well. And it's got a long list of features. It's only growing. It's got a lot of components. It is more complicated than the load balancer. This is one where we could probably spend a couple of hours alone talking about the pieces of the web application gateway and how they interact. If you just want to set up a very simple deployment, I've got a single URL, a single set of servers, and I just want to put a web application gateway in front of it. It's very simple. You deploy the web application gateway, and you get all of this. And then in the web application gateway, you'll update the settings for the backend pool. There's a default backend pool there. It is empty. And what it wants is either the name of each machine and its NIC, or if these 3 were load balanced using an internal load balancer,
Just load balancer.
the IP address of the internal load balancer. And that's a better configuration, because that allows you to scale this without having to update this. And then you can edit the health probe. How do I test those machines? And then that's it, if you just want a single URL. If you want multiple URLs, you'll create multiple listeners, one for each URL, and then you'll create multiple rule sets, one for each listener.
The health probe, is that TCP, a ping, PCV, or?
It's a HTTP or HTTPS test.
So what?
HTTP or HTTPS test.
Can you choose what the get path is and
Yeah.
the response?
Yep.
Okay.
Well, it's just looking for the 200, right? It's just looking
Yes, looking for a healthy load of that page or that URL. So ideally put in a page rather than just the root. You can have up to 16 of those listeners. I actually do have a customer who wanted to do that. They didn't win the job, but they were going to use all 16. And they can be either HTTP or HTTPS. So if I wanted to set up joelway.com with HTTP and HTTPS, I would need 2 listeners. If I wanted to add Cloud Mechanics on HTTP and HTTPS, I'd need another 2 listeners.
That's not another cost, because you're just paying. for
No,
the
you just pay for the instances
Right, okay.
of those
Well, they need to
web
rename the
application
boundary
gateways.
there.
Well, could you do a redirect?
That's what the listener is.
What?
That's what that listener is. It's just.
Oh, so you have
It is
to-
a redirect.
Okay.
An extra feature of the Web Application Gateway is the Web Application Firewall. So when you deploy the Web Application Gateway, you have the basic SKU, the medium SKU, you have the large SKU. The basic and the medium and the large allow you to turn this feature on at an extra cost. So I don't know the exact figures off the top of my head, but let's say the medium SKU was $60 for the Web Application Gateway per instance. I would need 2 of those for a production environment, so that would be $120 per month. The firewall would probably be another $300 for those 2 instances. So it's an extra cost. This gives me a layer 7 firewall. So I have my network security group giving me layer 4, understanding TCP, UDP, but not having a clue what a SQL injection attack is, or a malformed URL attack. The WAF, the Web Application Firewall, is a layer 7 firewall, and it's based on an open source set of rules called OWASP. I think it's on OWASP 3.1 at the moment.
Yep.
And that does understand bad HTTP traffic, SQL injection attacks, and all that stuff. When you deploy it, Microsoft recommends that you put it in monitoring mode by default. And that's what it is in by default. Monitoring mode is identify risks and threats, but don't block them. Because if you were to introduce this to an existing application, there's a good chance your developers did something stupid. And if you break the application, it's never the developer's fault for doing something stupid. It's always your fault as the server and networking person. So Microsoft say, put it in monitoring mode, look for the bad stuff. Talk with the developers, and if there is bad stuff that's bad due to bad code, you either disable those rules or you get the developers to change the code. I'll let you guess which one will really happen. And then when you're ready, switch it into protection mode. And then it will start blocking the bad stuff and stop those SQL injection attacks and all that stuff. So the WAF, deploying the WAF is actually pretty easy. The configuring is actually pretty easy too. It's just the configuring takes a long time. Because you create the rule, click save, go get a coffee. Even if you have to go 2 blocks over, you're probably going to get back before that rule update has saved. It's my one negative thing about the WAF. Create a resource, Web Application Gateway, or Application Gateway, sorry. And I am spelling badly. There we go. Click Create. And what do I want to call it? WAG E2E. What do I want? Do I want standard or do I want WAF? So standard is without the WAF. WAF is extra cost. So let's go with WAF. What size do I want? Let's go with medium. How many instances, how many machines under the covers will be running this service? 1, and they'll tell you we really don't recommend that in production. If you want high availability, put in 2 of them. But you can actually scale it out because each instance will give you so much processing power, so much bandwidth, depending on the size you've deployed. So if I wanted to go nuts, I might say I want 10 of these.
And that's 10 with 16 listeners each, right? Or
No, 16 listeners across the
whole
cluster.
thing. Wow. You'd be spending a whole lot of money for 16 things.
Yeah, but that would be a whole lot of web servers behind there.
Yeah.
Like, you know, PayPal.com is only one URL,
Yeah.
but that's a whole lot of web servers sitting behind it. Resource group, I can use existing, I can create a new one. Location, click OK. Settings. What virtual network do I want to connect it to? What type of IP address do I want to give it? I can give it a public or a private one, because this could be sitting in front of an application that I'm only accessing over a WAN connection or a VPN connection. So it could be securing my application against my Office network. because Office networks can have malware too. Idle timeout. What DNS name do I want on my public IP address? The default listener. So we'll create one by default for you, listening to just start. Do I want it to be HTTP or HTTPS? Do I want to configure HTTP2? Do I want the firewall enabled or disabled by default? Well, that's changed. That used to always be disabled by default. So enabled, and put it in prevention, though they would recommend put it in detection, and click OK. And then the last bit is just a summary of everything. You click that, and that takes about half an hour for it to deploy. So go have your lunch. Get a sandwich or something. Once that's done, we go to our web application gateway, which I do have running here somewhere. There we go. And then we configure our backend pool. So as I said, configuring this takes a long time, so I have it configured already.
Do you know what's the underlying technology behind
Nope.
Netscaler's checkpoint?
I would not be surprised if it was IIS, or because they use that for the app services stuff. So it wouldn't surprise me at all if they were using that for the load balancing. For the firewall, not a clue. I wouldn't be surprised if it was another VM running Linux or something, but not a clue.
But that would be Microsoft.
Yeah. So the backend pool is literally select the machine, select the NIC, or select the IP address or fully qualified domain name. So if I had a set of web servers with an internal load balancer in front of them, I would just put in the IP address of that internal load balancer. Click save, go update or refresh your copy. And then configure your listeners. I've actually configured 2 listeners here. joelway.com, www.joelway.com and test.joelway.com. So if we have a look at this guy, we can see it's taking the front end IP address and the front end port, which is TCP80, and I've manually put in the URL that I want that listener to listen to. So if I was to go to test.joelway.com, I will see that a VM called nywag-01 was sent that traffic. And if I go to joelway.com, well, it turns out the same machine on the back end got the traffic as well. So 2 different listeners. But those 2 different listeners could have had rules saying, actually joelway.com goes to that set of servers, cloudmechanics.com goes to that set of servers. And I could have also set up the rules to say, you know what, joelway.com, yeah, everything goes there, but joelway.com/media goes there. Quite possibly you might have multiple virtual networks. Why would I have multiple virtual networks? In a large environment, you're going to have lots of different application teams. So one application might be in one resource group, and you as an Azure administrator might say, I'm going to give you access to that resource group and nothing else. You look after your stuff, your network, whatever. Take care of your shit, I'll audit it. I'll use an Azure policy to do governance and stuff like that. Then I have another application. They have their own resource group, and I give them permissions to that. Again, I'll use Azure policy to do my governance stuff on that stuff. And then those 2 teams might go, you know what, I've got some data you might need, you've got some data I might need, but we're in 2 different virtual networks. We're isolated from each other. How do we share? How do we talk? Do we go across the internet? That's a bad idea. Instead, we take the power of software-defined networking to very easily connect those 2 networks together. Remember what I said about how NVGRE was? It was basically just a dynamic VPN that connects 2 NICs together. By default, it does that inside of a virtual network. We can extend that to other virtual networks in the same region or anywhere around the world. Very, very easy to set up. It's literally a few mouse clicks. And that's called VNet peering. So VNet peering, when it first appeared, was connect two virtual networks in the same region. And a few months ago, Microsoft gave us global VNet peering, where two virtual networks in two different parts of the world could be connected together using the exact same process. Doesn't even have a different UI. Now we have another option. If I want to extend this to multiple tenants, so one company wants to share information with another company, I can do that using a different option, which is based on VPN.
Does it cost more money? They have global VPN.
Yeah, it would do. And it's slower.
So that's basically the traffic you're paying for, right?
And so VNet peering, you're paying for data transfer, which is it's a micro cost. With VNet to VNet VPN, there's your data transfer charge plus the cost of running the gateway. And with VNet to VNet VPN, you're restricted to the speed that the gateway can handle. VNet peering basically connects a dynamic NVGRE tunnel between the two VMs that want to talk to each other, as long as they are in peered virtual networks. So the owner of this network has to peer to this one, and the owner of this network has to peer to that one. Once that handshake happens, NVGRE is allowed to extend those tunnels across those two virtual networks. And from the network security group point of view, they are one virtual network now. So as far as NVGRE is concerned, as far as network security groups are concerned, those are one network, even if they're in different regions. So from the security point of view, it actually kind of makes things a little easier. Another perk from this is these two virtual machines can talk to each other at the full speed that their NICs are capable of doing. So if I was running the crazy mad M128s, so that's 128 cores and 3,800 gigs of RAM. That machine can do 32,000 megs per second. That machine can do 32,000 megs per second, and they can talk across that link at that speed.
For just a cool $30,000 a month.
Some ridiculous amount of money. The M128 is about $15,000, $16,000 per month.
Yeah, I click on it every now and then. It's pretty fun.
But you can enable nested Hyper-V in it. So you can run a lot of VMs with your 3,800 gigs of RAM and 128 virtual processors. And they're expanding it. There will be a 12 gig of RAM option. They've announced that already. It's crazy. So global VNet peering basically just extends that across multiple regions. We have another option. If we need to go to a different tenant, we have VNet to VNet VPN. So this is basically a cousin of what we looked at earlier. I have a virtual network with a gateway running in a dedicated gateway subnet. And I have another virtual network with a gateway running in a dedicated gateway subnet. And a couple of mouse clicks here to say I would like a VNet to VNet VPN from here to this virtual network, and vice versa. And then a tunnel appears. The tunnel will actually appear and be reusable before the portal actually tells you it's connected. And now, this virtual machines here can talk to virtual machines here, but only at the speed of the gateways. So if this gateway could only do 80 megs per second, my packets will only go at 80 megs per second, no matter what speed this one could do. And it's a similar process to VNet peering. Admin of this network creates a connection that way. Admin of that network creates a connection that way. So I mentioned this already. If I do VNet peering, NVGRE is extending one virtual network into another, and I've effectively merged those networks. So if you have a VNet or a network security group rule that says I'm allowing all traffic inside this virtual network, that now gets expanded to the peered virtual network.
Does the global VPN peering cost extra money?
It's inter-region transfer, so it's outbound data transfer charges.
Just the data transfer?
Yeah.
Okay.
So 500 gigs would be roughly $40 per month.
What region?
Between regions.
Like-
Inside of a region, it's is it 1 cent a gig, I think. It's some small amount anyway. It's a microcharge. So VNet peering, very easy to set up. So what I've got is, I've got 2 virtual machines running in 2 different virtual networks. One is running in California, in West US. And I think this is the one I'm logging to at the moment. And I have another virtual machine running in North Europe, or Dublin. And it's in a different virtual network. They have to be because they're in 2 different regions. And I would like my California machine to talk to my Ireland machine. And as you can see at the moment, I'm running testnet connection, and that is timing out. There is no actual physical or a virtual network connection there at the moment. So this will time out and it will fail. Go on, fail. There it is, it's failing. And you can see it's just failed there. Timed out. Come on with the status. There we go. And you can see it has the success flag is set to false. So that failed. So what I'm going to do is go back into the Azure portal, home, the resource group set up for this demo. And this is the resource group. It's 2 virtual networks, 2 virtual machines. So go to the California network, go to peerings. I'm going to click add and say North Europe and select my virtual network, which is in North Europe, and trying to remember what it was called. That's a good question. What did I call you? Efficiency. I need glasses. My demos. Dub. There we go. Now when I do this, I have some options. First off, enabled or disabled. Is this peering going to work when I save it? I'm going to say yes, enabled. Do I want to allow forwarded traffic? In other words, if the network I'm peering to is actually peering to another network, so well, let's call it network C, say in Southeast Asia. If traffic from Southeast Asia passes through Dublin, will I allow it to this one? So I can check that box, allow that to happen. If this virtual network I'm in California has a VPN gateway, do I want virtual machines in the peered virtual network in Dublin to be allowed to use the gateway? This allows for interesting architectures. Or, the last one, do I want to use remote gateways? If there's a virtual network gateway in Dublin, do I want my California virtual machines to be able to use it? And I'll let your imaginations play with the architecture possibilities there, because you can start coming up with some cool ideas.
I mean, your micro-segmenting. Explain all that.
Well, I'll do some whiteboarding in a second. So that's doing that one. Let's go back and do Dublin and peerings. So you see the first peering is saved. Just got the notification there. Let's call this CA and pick. And again, I'm going blind. There it is. Click OK. Wow, time. Seriously, Finn. Come on. I'm going to have to do. It's okay. I only have to do 40 slides in 4 minutes.
It's a video.
That could be Sean Bossy. Oh, he will do 50.
You said you saved. I'm going to take its word that it's saved. Right. Normally you want to wait about 30 to 60 seconds after it's saved and then do this test. You don't want to do it straight away, because if you do it straight away it will probably fail. But if you wait about 30-60 seconds, that connection would actually work. So I would have extended my virtual network in Dublin to my virtual network in California.
Basically, 60 seconds takes the time if you agree.
Basically, set up the connections, yeah. So it's appearing as, for some reason, it is not appearing there. Right, because of time, I'm not going to troubleshoot. I'm going to keep moving very, very quickly. So, obviously networking can get complex. And you don't have access to the physical switches. There are no physical switches, they're all virtual, actually running on Linux. On the back end, we can tweak a lot of things. So we have different tools from Microsoft. The most important one you can use in Azure is Azure Monitor. So Azure Monitor allows you to turn on diagnostic settings, basically pull data from whatever it is you've deployed, a network security group, get the flow logs from that firewall and store them in a storage account. Get the diagnostics performance data from a virtual machine, store it in a storage account. Create alerts from those things. So if my CPU stays too high for too long, send me an email. Send my monitoring system an email. Integrate with my SIEM to get it to do something. Configure Azure Automation to actually do something automatically for me based on that alert or that action or whatever. Really, really useful. Log Analytics. Microsoft has spent a ton of money on Log Analytics. I don't use it. Log Analytics reminds me of BMC Patrol. Anyone ever used BMC Patrol back in like the 90s, early 2000s?
Yeah.
You spent a fortune on an enterprise management solution that was half written. They expected you or a consultant to write the rest of it. Log Analytics is that. Problem is they keep changing the damn query language. They actually completely rewrote it. I used to do training with it. I stopped because everything I had in the hands-on labs kept changing. So whenever I ran the class, people would go, this doesn't work, and I look at it and go, oh crap, they've changed the syntax again. Or they've changed the structure of the data or whatever. So I just got sick of the damn thing. But there's a few features that you kind of do end up having to use from it. But they're kind of abstracted. You don't use Log Analytics directly. It's kind of used as a data dumping ground. Network Watcher, for the networking side of things, is an essential tool. It provides a number of different things that we can use to troubleshoot our environment. So, Network Watcher, first thing is, I would like a visualization of my network. I would like something that I could put into a document. I would like to understand where my network security groups are associated. I want to know where my web application gateway is on my network. Topology will draw your network for you. Connection Monitor. Give me an idea of, or tell me if a packet can leave this virtual machine if it's going to a destination. Or can a particular a packet get from some source to my virtual machine? Flow Verified. Again, similar thing. Next top, routing. I can customize the routing in my virtual network using something called routing tables. I can say, instead of packets just going through the default gateway and then to the rest of the world, I would like them to go through some virtual appliance. Scenario there is I deploy some firewalls as an appliance, and I would like every packet inside my virtual network to pass through those firewalls, to be scanned, microsegment my virtual network. And the way you do that is with routing tables. The next top allows you to diagnose how that customized routing works. network security group view. You'll actually find this scattered throughout the Azure portal, but this allows you to understand the effective rules for a particular NIC of a virtual machine. VPN diagnostics. This one's useful for service providers. So they've got some customer connecting into a virtual network using a VPN, and the customer keeps complaining that the VPN connection goes down all the time, and you suspect that they keep dicking around with the settings of their firewall. This is your way of finding out. It'll tell you, okay, the connection's gone down. Why has it gone down from the Azure point of view? Packet capture. Using an extension or an agent in the guest OS of your VM, capture the packets on that NIC and then open them up in Wireshark so you can see what's been going on in that flow. Connection troubleshoot. Use that same extension to drop packets onto the NIC of a VM and try to send them to another NIC and see if they get there or not. If they don't, explain why they didn't get there. Was it a routing issue? Was it a network security group issue?
Is that extension called Smart?
No. Flow logs. This, to use it, requires that you deploy that log analytics thing, which does cost money. And that's a per gig of data consumed for monitoring. But flow logs allows you to get a deep understanding of the data that's flowing through your network security groups. And it's not just an analysis of what's going through, what's bad traffic, what's good traffic, but getting an understanding of the application traffic itself. Diagnostic logs. Using Network Watcher, we can go into diagnostic logs and we can turn on the logging of all our networking pieces in Azure and dump that data into cheap blob storage in a storage account. Very useful. It's all stored in JSON, and so if you want to read JSON, you can. I have done. If you have a tool that understands how to read in JSON and present it to you, you can use that too. And traffic analytics takes this NSG flow logs data and presents it in a nice UI. Makes it more understandable, easy to consume. So I was going to do that, but considering how late I'm going, I'll keep moving quickly. Routing tables, I've quickly said what that was. There are system default routes there by default. Basically is, if it's on the local network, just send it to it straight. Or sorry, in the local subnet, just send the packet straight to the machine. If it's outside the subnet, send it through the default gateway. That's your routing tables. Simple enough. We can customize that. So if we want to say all traffic going to the internet must go through a particular appliance, scan that traffic. We can create a routing table to say anything going to outside this virtual network must go to this IP address of this Azure VM. Again, we can also use that for controlling traffic between VMs in the same virtual network. So I could deploy my Brocade firewalls, my checkpoint firewalls, whatever it is, and give them an internal load balancer IP address. So not just an external load balancer, but also an internal load balancer IP address. And now if my web server wants to talk to my database server, I can update the routing table to say, don't just talk straight to the database server, go through the firewall that I've spent a ton of money on. That it, not just do the layer 4 stuff, but also the layer 7 stuff. See if it's good traffic. Look for malware activity and stuff like that. So,
how difficult is it to update those?
oh, it's really easy.
It's still within the ARM.
Yeah, it's in the Azure portal. And it's similar to network security groups. So, I talked about peering and gateways. We have an architecture called hub and spoke. Let's say I've got two virtual networks with some VMs. Okay, we'll call this A, we'll call this B. And I would like site-to-site connections to both of those. High-speed connections. I could, in theory, put a gateway here and a gateway here. But if they're both high-spec gateways, that could be expensive having two gateways. what if I could connect both those networks with one gateway? So alternatively, I could create a virtual network whose only job is to run a single gateway. So that could give me my high-speed connection back to on-prem. And then I will peer those virtual networks like so. And when I peer those networks, I'll allow that one to use a remote gateway, that one to use a remote gateway, and allow this one to let the other networks to flow through this gateway. That's what we call a hub and spoke. Now when packets come in, they will automatically route like so. And what I've got to make sure is when I'm configuring my firewall down here, I don't just put in the network address for here, but I also put in the network address for A and B. So my local network knows how to route to A and B, not just to the hub network here. So I'm able to quite happily route to here and here. But I'm not able to route like so. There is no path. So there's two ways I can do that. The first is I could do that peering. We refer to that as a mesh, or some people would call a mess. Because if you have lots of VNets, that will get messy. That's one option. Another option is deploy a virtual machine or a virtual machine cluster. So let's say that's 10.0.0.4 as a router. Then I could update the routing table of here to say if I want to get to B, I will route through that IP address. And if I want to get from here, I will say if I want to get to A, I will route through that IP address. And that gives me the ability to connect lots of networks now through that hub network. I had theorized, using all this peering stuff, that there was a cool option I could do. Oh, I've never drawn North America before. Okay, so for you North Americans, I apologize because I'm about to try draw your continent and it's going to suck. So, oh God, that looks like Africa. So, there's the Americas.
I like it.
Right? And let's say there's a whole lot of stuff here, and there's India. I'm sorry if there's anyone from India here, because I've never even attempted to draw India before. I did American geography in school. That's bad. Let's say I've got an office here in New York, and I would like to connect to New Delhi. I could buy a WAN. That'd be expensive if I didn't have a WAN before. I could do a site-to-site VPN connection. The latency on that would be crazy because the packets don't go in a straight line. What they're probably going to do is something like that. So the latency will be crazy. What I could do instead is deploy a virtual network in East US and do a site-to-site VPN connection from my New York office. Then create a virtual network in one of the 3 Indian regions and do a site-to-site VPN connection. Then do global VNet peering. Set up a router, and take advantage, did I say it was, of the 90.6 petabytes per second bandwidth that Microsoft has between their regions.
Shared between 5 million people.
Yeah, but really low latency, because that's a dedicated connection then between there and there. And I'm probably looking at maybe 20 milliseconds here and 20 milliseconds here.
Between the 2 regions.
Between there and there, and there and there, and then whatever the speed of light is between those 2 regions across the wires. effectively, I've just done what I would have gotten from a WAN provider. Now I don't have...
Probably better in some cases.
Quite possibly. The only difference is I don't have an SLA on that piece and I don't have an SLA on that piece because of site-to-site VPN. But that would give you, I theorized that would be a cool solution. And then I saw someone on Twitter last year who said they had done it between Germany and Australia and it worked out awesome. They got really low latency connections between Germany and Australia. Much better than they were doing from a direct VPN connection.
And this year, I wrote a name and I sold my house, my liver, my wife. It cost way too much. 4 minutes.
4 minutes. Right, traffic manager. Cool service. Whiteboard it, it'll be quicker. Traffic manager is internet load balancing and failover. So what I can do is I can create a traffic manager profile. That is a DNS name that Microsoft gives me. And for my www.whatever, I can actually create a CNAME to point at that. And this thing looks for what I referred to earlier as an endpoint. An endpoint is an IP address and a DNS name. And that I get from Microsoft in the form of a public IP address, which could be a bunch of load balanced web servers, let's say running in East US. What if I wanted to scale out my application to include West US? And I wanted to have those people have low latency connections. Well, I could deploy another set of web servers in the West US Azure region and extend Traffic Manager like so. And I can configure this Traffic Manager profile to be what we call performance based. What that will do is when the end user browses my site, a test will actually be done to see which of these they will get to quickest. And when they browse, Traffic Manager will send them to the one that is closest in terms of latency. That configuration could also be different. I could say East US is my production, West US is my DR. These machines might not be there at all. I might be replicating them using Azure Site Recovery for Azure VMs. And if there was a problem in East US, I would fail over my virtual machines. They would now be available on that public IP address. And I would use Azure Automation to change that Traffic Manager profile to point to here instead. And now, when I browse that site, I'm no longer going to East US, I'm going to West US. And that gives me a quick failover. Now I said that whole thing was based on endpoints. An endpoint is an IP address, a DNS name. So this could be my web farm running in AWS, and I could be load balancing with some websites running in GoDaddy. And Traffic Manager might be the only piece of Azure I'm actually using. I've got a customer who's doing that, so a Microsoft partner who's doing that. They don't send the bill to the customer because the cost of doing that service is actually lower than the cost of a stamp. So it's a cool service. You can use that Traffic Manager in lots of different ways. We can load balance, we can do performance based, we can do failover. We can use it in different ways. We can say that this is my production environment, this is where I'm building my next production environment. And when I'm ready to switch over, I redirect the Traffic Manager profile to the different endpoints. And then what was production is now going to be version 3. And I start building it. I think they call that blue-green. So Traffic Manager, very cool service to set up. Third-party NVAs, well, you can do it. This is a reference architecture from Palo Alto. So what they have here is a pair of their appliances. They are Linux virtual machines. So the cost of these virtual machines is the cost of the Linux virtual machine plus the cost of buying the Palo Alto software. There's a public IP address with a public load balancer. And they have a front-end subnet. So the virtual machines actually have 2 NICs each. One's connected to a front-end subnet, the other's connected to a back-end subnet. Traffic coming in goes through the load balancer, and then depending if it's a basic load balancer, this is active-passive. If it's a standard load balancer, this is active-active. And then traffic flows through the firewalls and comes out through the internal NICs, and then can route through the other subnets. So I can have my different application subnets back here, so you can see web, business, database, and I have NSGs here as well. Now if I want to micro-segment this, I can create a routing table on each of these subnets to say, if I want this machine to talk to that machine, it must go through this IP address. Or if I want this web server to talk to this business machine, it must go through this IP address. Now my firewalls see everything. I know I attended a presentation by Checkpoint, and they said that if they had been there doing that micro-segmentation for the NHS, so the health service in the UK, they would have prevented them from being shut down by WannaCry. Because their firewalls understood that particular malware and would have stopped it from going from machine to machine. Basically, one machine would have been infected and it would have been isolated on that site. So we can also use our networks in platform as a service. You want me to stop?
Yeah.
Okie dokie.
They all can go to the Masterclass.
So lots of different reference architectures and stuff like that. So you get the slides from Alex. So thanks very much. That was what, 4 and a bit hours.
Well, thanks so much for coming to your.
So yeah, thank you folks.
Well, of course, you can talk to Aidan about if you want to join for the masterclass. I have to